I am CTO of the Essenza GmbH, which is one of the organizing teams beside the InFi. I have the pleasure to welcome you to the 12th Semantic Web Day in Leipzig. We prepared a nice event for you today. We organized a keynote, which I will introduce later, and 16 talks in 3 sessions. Right after the keynote, or after the coffee break after the keynote, the first session is about knowledge graphs and large language models. Then there's a lunch break, and after that we will have a session on knowledge graph use cases in industries. All presentations are from industry partners, and all over we have around 40% of our talks now today from industry partners. And in our last sessions we will have presentations about ontology engineering and semantic web technologies. The program ends at 4 p.m. and at 6 p.m. we are inviting you to the Semantic Beer Garden in the Moritzpassai, which is 50 meters from the town hall in the direction of the Augustusplatz. As I said, I'm part of the organization team, and this is the whole team, so thank you all for organizing this with me today. And as a next step, I just want to introduce you our keynote speaker, Ben Gardner. He is, welcome. He is head of a research and development team at AstraZeneca for data mesh and semantic infrastructure. And his keynote is about enabling new medicines with FAIR Data-centricity, delivering linked data inside the enterprise. So, welcome, Ben.
So thank you very much. Very honoured to be presenting here. I was trying to remember the last time I was here. It was for a nice semantics conference, maybe 10 years ago. So it's very lovely to come back to Leipzig and to present on my current work. I'm going to talk about how we're using FAIR data inside AstraZeneca. And what I'm trying to bring home is how we have to approach it from an enterprise perspective, which is different to the way that we approach it on the web. But we take inspiration from the web, and we're obviously guided by those 10 principles and 13 sub-principles that exist around FAIR data. I'm going to talk about it in 3 sections. I'm going to first talk about the new science that we're enabling and how we're trying to move people away from doing search to doing information discovery. Then I'll talk about standardization as the only way to scale. And this isn't just about the data, this is also about the infrastructure that we use. And finally, I'm going to talk about our approach to FAIR data-centric information architecture and how we're hiding the semantics from the rest of the business to aid the adoption. So, why are we doing this? We're doing this because the science is evolving and we're asking more and more granular questions of the populations of patients and looking at diseases in much more granular form. So we can take the example of cancer. Many years ago, we just talked about people having cancer. Now we talk about people having cancer of an organ. And then we started to talk about cancer of cell types and non-small cell lung cancer. And now we talk about the mutational profile of the cancer. And as we drive deeper and deeper into the understanding of the disease, the need to have subjects, patients that match that profile to be able to do data science on and to gain new insights requires us to combine data from across broader and broader pools of different data sets from different groups within the company, from different clinical studies that have been run within the company, and different functional groups, and with CROs and academic collaborators. And all of this means that we have to move from talking about the clinical study to talking about the subject to talking about a subpopulation and the samples within that population. So we're moving our science from what was a very fragmented state to an integrated state where we can talk about it and explore it in this fashion. So the tool that we've built has a front end which we refer to as scientific intelligence, and this is where the scientists are able to start to explore the information space. And we started by gathering use cases, so we've always been very pragmatic and very use case driven. I'm not going to read through these examples, so I'm sure you can follow up afterwards and look at them, but essentially what we went through all of these, as all of you will do with your use cases, is to look for the entities that exist within the questions and then identify where that data can come from and then how do we pull that together. And so we have our use cases, we identify our sources, and I'll come back to this idea of platforms and the data mesh architecture that's associated with that. And then we bring it together through a knowledge graph. We refer to this as a knowledge map, and I actually introduced this when I first joined AstraZeneca. There was a lot of conversation of we need a knowledge graph, right? And is it a label property graph or is it a RDF graph? And there was a religious war going on, as I'm sure you've all experienced in this conversation. And so what I pointed out was, well, there isn't going to be one graph, there's going to be lots of graphs. And we're going to use different graphs for doing different things and different technologies for doing different things. And I said, there is this idea of a knowledge map, which is really about integration. It's about helping people navigate and explore information space. And that's what we're building with an RDF graph. And then there are analytical knowledge graphs, which are really like applications. And maybe they're the right tool to be using as a label property graph. And just introducing that as a conversation created enough headspace to allow people to actually work and to move away from the religious war and for us to progress that conversation. Now we need to, we all know that building a knowledge graph and our graphs are super cool and we're really excited by them. But my end users care about an interface. They don't care really about how the data was put together or anything of the hard work. They want a nice interface that they can use. So we use a tool from a company called Ontoforce. I keep mixing those up, and apologies to my colleagues here on that. And that's our scientific intelligence, so that's our front end. So people can search that and then they can submit a request. And in our case, because we're dealing with clinical data, we're dealing with subjects who have participated, they need to go through a consent and compliance process. So we then have this process called an IDAP request to request access to those individual patients. We have in here essentially, and apologies, I can't really show you the data. I hope you can appreciate this is clinical data of individuals and we have to respect their privacy. So I can kind of show you the general structure. So we aggregate information around studies, the subjects that participated in those studies, the samples that have been taken from those subjects, and then the data that has been generated on those samples. So this could be digital pathology, so immunohistochemistry, staining from images, or it could be gene sequencing, proteomics, metagenomics, etc., etc. But essentially, we take all of those observations around that and bring them together. And you can see the graph here, and at the study level, we have information about basically summary information about the study and information specific about the study. So the number of studies by indication or by drug, but also at the individual study level, the title, the status of that study, the phase that it went through, the number of patients, etc., etc. And then as we move down into the subject, we now have summary information about how many adverse events of a particular type were observed at a summary level, whereas at the individual level we can go down and actually look at their demographic information, the adverse events, the lab tests that were performed, their vital signs, those sorts of things. We don't have all of the clinical data that's generated around the study. This is about the data that helps the scientists find the right subset of patients that they're interested in, and then they request that and they get access to the full data set. So we have this sort of degree of separation that occurs. Get down to the specimen level, so these are the blood samples or the biopsies that were taken. And again, here we can say the number of samples that were taken, the sorts of tissue that was extracted, the preservation method, the availability. Is it still available as in inventory? And people can now ask for if there is wet samples in our freezers that they can request as a result of doing data science, so that they can then test their hypothesis by repeating new science against it. And finally, we get down to the observations. And so these, we can start to look at things like the number of images that were captured, and we record both the medical images, so X-rays, MRIs, etc., as well as things like the digital pathology staining of slides and so forth. And we can go down and tell you about the variants that were observed, so the tumour profile of a patient and those sorts of things. So we get down to quite granular information, and all of this is about driving people to be able to find data. Now, the use cases that we then see people using this for are doing a number of different things, and these tend to be difficult queries that they weren't able to do previously, or if they did them, it took them a very long time to do it. So there are three examples here. One's a landscape review. So we're often trying to understand, how much data do we have across this profile? So it might be the different stages of a cancer and the different types of populations that they generally see, and they want to know, how much data do they have that has a proteomics measurement and has a particular staining type analysis that's been done on it. And the questions they're asking strategic is, should they be investing in purchasing more data of this type to help fill out the holes in that matrix? These things typically take up to 6 months to pull together, because it requires the person pulling the information together to go around the various different labs and talk to the various different experimenters to gather that information together. We can now do this in minutes. It's just a query. Right? So whereas it was only done where it was really needed, now you can just generate these views whenever you want. Study design optimization is another use. You're trying to learn from the past as to maybe how many subjects you need to achieve statistical significance in the study, so that it's powered correctly, as they refer to it. And so you want to look at legacy patients with a similar profile to the one that you're going to include in your future study, and see the variability of the data for the particular lab tests that you might use, and that will help you select the different lab tests that's there. Again, this can take weeks to request someone to find the studies that might be relevant to you, to get the data back, and then you've got to align all the data, and then you can do your analysis. We can now enable our study designers to do this on the fly using data directly within this tool. They don't even have to submit a request for the subject, the data in many cases. And finally, that cohort selection, that one that I started with, I have a indication, so non-small cell lung cancer, I want to treat it with this drug, and I want to know what this particular adverse event, and does it have this sort of imaging around it. That was weeks again, and now it's down to minutes. And these are really enabling the scientists to do it. We recently had a case where one of our data scientists wanted to produce a model for neutropenia. So neutropenia is an adverse event during chemotherapy, which results in your blood immune system basically being suppressed. You can put people on recovery treatments if you can spot it happening, and that allows them to maintain additional rounds of chemotherapy. So it's really important. It can have significant impact on patients. The team he was working with only knew of 2 or 3 studies that would have the relevant data that they needed. He was asked to have a look in scientific intelligence. He managed to over double his his sample size, and also had confidence that asking for those samples, that data sets to be processed would result in data. This is exactly why we built it. We're enabling that new science by helping people to uncover our unknown knowns. Now, the really big challenge with those questions is getting people to understand what is now possible. And the other issue is that scientists only ask these big, complex questions maybe once every 6 months. Because once they've got their data set, they go off and they go and do their work for the next 6 months, and then they come back and do it. They don't build familiarity with the knowledge graph and the underlying structure, and therefore it can be quite intimidating for them to know exactly what's the best strategy for them navigating it. So we're building these hugely powerful tools, and as we bring all this data together, we're building something really quite complicated for people who aren't in there every day. And it's very difficult to build a UI that is really that simple. Now, maybe we can come on to LLMs helping us in this space. But what I equate it to is, back when I did my PhD, I went to this really big building that was full of books, all this aggregated knowledge, and there were these librarians that could help me navigate this space. I do wonder if we need to bring the librarians back, and this is what we're exploring in our team now, is to try and bring information practitioners back into the fold and to help them use this so that they can help people to navigate this information space. So I'm now going to talk about standardization. And it's the data that's important. Let's not get hung up on the tooling that sits underneath it. Or let me put it another way. If you have to do it all yourself, you'll kill yourself. And that's what we found. So this is just to give you a picture of what we're dealing with. We're dealing with data coming from about 13 different systems, which we now have platforms that aggregate the information across those systems and try to provide us a data product that we can consume from each of those platforms. And I'll come back onto this, but it's the study, the subject, the imaging, the omics, and the sample, plus we're now looking at real-world evidence, so health payer and hospital data, and we're starting to look back into the preclinical space, into the safety data as well, so we can do translational medicine across this. Scale, and as you broaden it, brings a headache. And we tried to do all of this ourselves. And when we started, we were having to help capture the information, help curate the information, help verify the information, and then we could use it. I have a team of 6, right? This was killing us, right? There was no way we could do all of this. So the questions we had were, how do we simplify the way we do our verification? Could things like the data mesh and data products help? How do we standardize that? How do we enable other people to do it and to allow us to maximize our data engineering skills without having to do everyone else's work? So how do we better manage that graph ecosystem? We spent too much time just managing infrastructure because we had the smorgasbord of open source tools here and some proprietary tools, and we were perpetually spending my rare and very valuable scientific semantic engineers who spent their time managing the infrastructure and getting it all to work. How do we evolve from virtualization? So we were using a virtualization solution. What we realized is that in our case, scientific data is pretty much static. Once you've done the experiment, you really doesn't change. So there's no value in virtualization. You can process it once, just make the most of it. And then also, how do we orchestrate all of these things? Because it was, to be honest, it was a mess, as you might imagine, with all of these independent pieces. And then the other question we had is, how do we democratize the graph? How do we make it easier for people to take advantage of what we've put together? How do we make it play nicely with the rest of AstraZeneca? Because, you know, the rest of the world that we live in is a relational world, and they have a whole set of relational tools. So how do we play nicely with it? We can't expect them to write SPARQL. So how do we complete that journey? And can we extract more value? So the answer here is just standardize, standardize, standardize. You know, don't be precious about your cleverness at being able to build and combine the best in breed of open source tools. Look to see how you can do it. So from the verification perspective, we had the data mesh movement going on within AstraZeneca and the idea of data product. So the idea there is that a domain produces a data product which is designed for reuse. And so we now encourage our domains that were formed to produce an aggregation across all the subsystems that they have within their domain to present out and to share with the rest of AstraZeneca. So now I'm no longer going to source systems, I'm going to a platforms product, and they're responsible for the cleaning up and the verification of the data. And we'll talk again about how we're driving better interoperability into their data. We moved to using a combination of what turned out to then be default infrastructure, and basically we use Snowflake now for our storage and DBT to do a lot of our cleanup. Now we do a lot of work, and this was a really important piece. We chose to do an awful lot of data cleanup and data wrangling in SQL because we can get an awful lot of SQL engineers, I much prefer to use my semantic engineers to do semantic things rather than just doing data wrangling and cleanup. Right? It's not to say one is more important than the other. It's just that I can get an awful lot of engineers with SQL skills. So we focus on doing as much cleanup as possible in the SQL space. And so we've standardized our tooling there, and we use Airflow as our orchestration in that space. And then we also do quantification of FAIR. So we've introduced Python libraries, mainly based around the Great Expectations library, to start to quantify every step of our profile. So we check the data on entry, we check it all the way through, and we check it on export. And the really other nice thing about DBT is we get auto-cataloging, or auto documentation of all the transforms that we've done during the process. So we can really produce, if we share that data, we can produce it with a full lineage background around that. And even better, we can get other people to use this because it's all part of the standard stack that's now being adopted by AstraZeneca. So the patterns that we've identified, we can share as learnings to get those platforms to help clean up their data. We can take the SQL that we've generated to do the data cleanup, and we can just pass it to them and say, well, this is what you need to do, and then they can go and implement it. We chose to go with corporate memory now at our graph level to manage that ecosystem. And we went there because it's a solid bit of German engineering, to be brutally honest with you. It is well thought through. It eliminated the smorgasbord of things that we were maintaining. We could go to a sensor and get them to, well, they took ownership of packaging it up, managing the security updates, managing the patches, evolving that ecosystem, introducing new capabilities. My engineers can now look at working on the data rather than the infrastructure. And that's what we want to do, it's the data. And finally, the other piece that comes with this is both some really nice import data pipelining capabilities that allow us to now have engineers who came from the SQL world to work with semantic mappings. My BA, okay, my BA Nicola is not a normal BA, I will accept this. But now she actually does an awful lot of the mappings herself. So the proof is in the pudding of what corporate memory promised was that they would lower the entry level to be able to work with semantic tools, and that's exactly what they did. And at the other end, it's really smart that the same pipelines that you effectively use to import your data into the graph, you can use to, or the same tool set you can use to export the data back out into the various formats that want to consume. So we're getting it back into the tooling space that the rest of AstraZeneca works with. Now, all of this is underlined by us producing controlled vocabularies, so sets of terms that are defined against a class and contain the URIs, or as we refer to them as PIDs, so persistent IDs. We've invested and continue to invest in our URI patterns. I don't think I realised until we started to do this just how much concrete I was pouring when we set our URIs, and getting those right and getting those consistent is absolutely at the heart of everything. And I still have sleepless nights over our conversations around URI patterns because chipping out concrete is very hard. And we have a reference model that we construct in OWL, and we build this outside of corporate memory, and then we import it. And our reference model is at the heart of everything that we do, and that's what we're going to talk about next. We're going to talk about this information architecture and how we bring it together, and how we're driving FAIR into our organisation. So I'm sure you're all familiar with the idea, or hopefully you're familiar with the idea of data-centricity, the idea that the observation that our data outlives all of our applications. So why allow our applications to shape our data? We should invest in the data and then have our applications visit the data. For us, I'm going to slightly bastardise that term, and whilst I say we're doing data centricity, I think the likes of Dave McCoon from Semantic Arts would say that I'm really building a domain model and I'm driving around that. And yes, I am. I'm driving around the science that we do in R&D. And what we're doing is we're transforming the language in many respects from the underlying systems that capture the data and pivoting it into the language and the concepts that the scientists are using so that they can start to query it in terms of the things they're interested in rather than the systems in which it was captured. Now, this slide, I'm not going to read through any of the text on it. I'm sure they'll be shared afterwards and you can look at it. Really all I'm saying is that the blue ones are system-centric FAIR. And the idea here was to start to introduce the idea that there could be different degrees of fairness. Now, we all know that FAIR is contextual, but this was at least a way of starting to get the organisation to think about quantifying FAIR. And we developed this with the information architecture community. And we said levels 1 to 3 really represent system-centric, and then levels 4, 5, and 6 represent knowledge-centric. Now, I'm not going to talk through this slide. What I'm going to do is talk about these degrees of fairness in terms of a shopping experience. So, the lowest level of FAIR, I am going shopping, and I go to a junk shop, and I'm looking for shoes, footwear. And everything's random. There's no organisation whatsoever. There's no sense of providence. I might find a flip-flop and a diving boot. Yes, they're both in the class of shoe. I would be very interested in the social situation which would require me to use a flip-flop and a diving boot. If people have suggestions of a fancy dress party that I could attend, I'd be interested to know. But the point is, it's random. You don't know anything about what you find. Good luck. And then we can start to think more and more organisation. So the first step up from this might be a car boot sale. Every stall at the back of a car has what that person is selling. They've probably organised it to an extent that the DVDs are here and the books are here and the children's toys are here. But the organisation is bespoke to them. You don't know what's going to be on their stall versus the stall next to them. If you want to find a thing, you're just going to have to search through the entire market to try and find it. Good luck. And then we can start to see more organisations. So we can think of something like a street market, maybe a Moroccan street market. And here, you start to see aggregation of stalls of a type together. So you might get all of the spices in one area, you might get the vegetables and the fresh meats in the other, and so on and so forth. And you can go to, say, your spice stall, and you can see that the different spices are well labelled. You can talk to the proprietor about what each spice is, and they can maybe tell you, oh, well, this one comes from that farm, or this one comes from this place. But the layout of the stall is going to be bespoke to them. It's going to be different to the one next to it. You've got no sense of quality, maybe, or authenticity, not authenticity, but, you know, provenance is really quite limited, and so on and so forth. So again, it's more organised, but it's not really there. And we would equate these three levels that I've just talked through as being system-centric behaviours. If we think of shopping and we go to our local 7-Eleven, sorry, I don't know what the German equivalent of this is, you know, your local corner small market. And when we go in here, we see that next level of organisation. So the goods are organised into aisles. The aisles have labelling above them. The categories within them, so you might see baking goods, vegetables, you might see cleaning products, right? They're all gathered together. And you can go there and you can pick up a product and it says provenance, where it was made, it will tell you about the ingredients and so on and so forth. So you're now starting to deal with much more organised data. And the other thing that comes with this, if you go into a 7-Eleven almost anywhere in the world, that same navigational structure is existent in all of them. So you can quite easily navigate from one to one. So you're seeing at least scaling across instances of this experience. The obvious next step up is something like a supermarket or a hypermarket, where just the scale of products now are so much greater. But the other thing that we see when we move there is, again, all of that structure that we saw at the small scale in the local mart, but now we're starting to see displays of things that are around events and often seasonal. So we've just come out of Easter. So in the UK, we will see all sorts of things gathered together in a single display, not just the chocolate eggs, but maybe the lamb. We like to have lamb at Easter. There might be some wine. There might be some gift cards, those sorts of things. So it's starting to present the data in terms of the experience that people are interested in, rather than just the organisational layout on the standard form. When we finally get to what we would refer to as our level 6, we are really moving away from the physical limitations of the products being displayed. So you can go to Amazon and you can see almost anything there. Yeah? You can explore in any direction. You've got recommendation engines suggesting things. So they're almost creating those experience displays on the fly for you. And we're also seeing services being built off the back of this. And the example I was quite struck by when I started doing this was I was looking to cook some slow-cooked pork. And I just Googled recipes, and I found one I liked, and I was reading through it. And there was a button that said, add the ingredients to your loyalty card. So I was on a recipe website, click the button, and it would have assigned all of the things I needed to do that to my Tesco's loyalty card, so that was then added to my next order as a thing. So my experience has been completely transformed from having to go and find the recipe and find the components to, oh, I'll just have that because that's what I want to cook, right? And it's this transformation from the individual things to the experience that is the really important piece here, and that's what we're trying to deliver. So how are we doing this? Well, I'm going to use this this framework, this device here, to talk about our approach. What we do is we've recognised that to get fair data, we need to combine the reference model, the control vocabulary. So the reference model describes the things that we have. The control vocabularies categorise and describe those things that we've identified, and then we put the URIs back into the data. And if we do that, we can then build our knowledge graph. And I'm going to talk about these in this, each of these legs of this, as my colleague Derek referred to as a three-legged stool. He was so impressed that he actually went away and made a stool. So sometimes your conceptual models do get turned into physical models. And I'm going to talk about it with meaning, and I'm going to start there, and in the words of Dave McCoon from Semantic Arts, start with meaning. So, we're going to talk about the model leg. Here, in most companies, and most projects I imagine as well, will have conceptual models that you will have put together. In large enterprises, they're probably a diagram that sits in IDERA that gets updated once every 3 years. It contains a rich set of information, but it's a conceptual model. The information architects look at it and they think this is really nice, but nobody else cares about it, and it gets lost in translation all the way through to the physical model. We really like it. We really like the effort that the information architects put into disambiguate and identify the entities in there. And so we take the conceptual models and use them as inspiration. And within these models, you have the blue folder or boxes in there are the classes, essentially. And what we decided to do was to build small models that we refer to as our entity ontologies that correspond to the classes in there. And we did this so that we could have modularity and that we could evolve them and version them independent of each other so that we had great flexibility in going forward. We assumed at the start that we would get it wrong and we would have to evolve these things as we discovered the data that would allow us to expand the use cases that we had. So we build our ontologies, and in these, the orange post-it notes, which you can vaguely see, represent the classes, and the green represent the attributes in there. And you can see that within an entity ontology, there is a top-level class, and then there are a series of subclasses as well within it, because they model things like a clinical study, well, a fragment of a clinical study, or a biosample, or a drug, and they are significant models unto themselves, but we built them as components. And then what we do is we import them into our application ontologies that we create. So we pull those forward and we put them together as Lego blocks to build these application ontologies. And then the FAIR diagram on the far right, the honeycomb thing. This is a motif that I picked up from a guy, Dan Gershwind at Amgen, and it's a really powerful device for talking to leadership and abstracting them away from trying to present you that Miro board diagram of an application ontology. If you can present it as this honeycomb where the filled in hexagons represents concepts and the links between them represent the major links in there. I can talk about it in terms of here in the center, you've got clinical study, and then the blue one to the left is drug, and then the one above it is indication. So you can say, okay, I'm interested in clinical studies where drug X and indication Y were run, and you can start to talk through the hexagons, and it becomes really easy for them to understand or conceptually understand what you're talking about, rather than trying to walk them through a model like the application ontology that we've got there, or even trying to show them a turtle file if you're being particularly mean and vicious. The whole point of this was to really go for an acceptance that this was going to be organic and that we were going to evolve the reference model over time. We started with 3 different groups who were all working around similar sorts of space, and unsurprisingly, you see a common motif of basically clinical study drug indication falling out, as you can kind of see in the top model. And then we saw that in the model we were doing with precision medicine colleagues, and then there was another model going on, the Thrive one in oncology. And we said, okay, can we bring these together? This was the proof of the pudding of taking our entity ontology approach. The answer was yes, and then we've been able to continuously evolve it based on the emerging scientific use cases that come forward. So we add complexity in rather than try and design everything up front. We take an agile approach to this. The next leg is the control vocabulary. So we've identified in the model, the things. We want to be able to describe and to decorate the things with the categories that they apply to. When we first started our first go at this, we were all working as independent groups, and the team that were the reference data management team who were doing this did their best, and this isn't a criticism, it was a learning. What they ended up with was essentially lots of vocabularies being supplied from various applications that they were overlapping, so the same concepts would appear in them. So what we effectively had was just a pile of Lego bricks on the floor with no ability to really have any control. So we introduced the idea of a data office, and the data office is it's like an editor. It's trying to drive consistency of house style across our vocabularies that we build, and to build them in a coordinated fashion, and to build them as atomically as possible. So we might see in the data blood EDTA. So this is a column that's showing the biofluid that was taken as a sample and the preservation method. So blood is the fluid and EDTA is the preservation method. We wanted to not build these concatenated vocabularies. We wanted to build a CV for blood, or CV for biofluid, and a CV for preservation method, and then allow people to bring them back together. And this is like a faceted CV within SCOS. And by doing that, we had absolute atomicity in our build of CVs. And the first level of that is what we refer to as local. There has been semantic drift around these terms since I produced this slide internally, but essentially a local CV was a CV that is atomic, designed against our framework, but is for a very narrow use case. So it might be for just a group that wanted 2 or 3 terms in there. And then we see foundational CVs really being that CV as it starts to mature, and we add new terms into it, and we extend it, and it now is being used by multiple groups, and so on and so forth. And then we allow collections and faceted CVs, these ideas within SCOS that allow us to create slices through one or more control vocabularies that people can then utilise to actually include the values in their data. And we use SCOS Excel, and we've extended it slightly. Here we see a CV for a concept scheme for country, and here we see the example of Switzerland. And on the right-hand side, we can see the different preferred labels for the countries and in different languages. So we're providing language tags in there as well. We include the alt labels. We include hidden labels for spellings and things like that. Terms that we want to keep a record of, but we don't want proliferated. And then we also include, for all of the labels where it's appropriate, the schema that it came from. And this is really important for us to actually turn our control vocabularies beyond simple lookup lists to actually being a Rosetta Stone that allows us to translate between schemas. So I can say, oh, I want the English country names. Or I could say, I have the ISO 316 two-letter code CH. Translate me that to our pref label. But equally, I can say, oh, I need to translate the ISO 316 three-letter code to the two-letter code, and I can use the CV to do that and that translation as well. Most people don't care about doing that, right? Those of us in the semantic space really do care about being able to do these really cool and useful things. Most people just say, actually, I've got this term, can you give me the URI that I need to include in it? So we try and hide the semantics and allow people to just deal with the thing that 80% of the world wants to do. And that's really where we now start to talk about the data. So that level 4 data, that first local store, that local mart, for us, level 4 data, or for me, level 4 data means that you have catalogued your data. So you have recorded the data set, the data system, the data product in the catalogue. So people could search for it and find it, and you probably provide some minimum metadata around that. Once they've found it, there is a mechanism for them to request access to it, and there is some documentation about the reuse, so licensing or constraints that exist around it. But this hasn't done anything for the interoperability, if I want to combine those data sets, I've still got a lot of work to do. So I couldn't resist this to say that we were far from FAIR, and we had to go further. And so if we want to go further, we've got to tackle that hard problem of how do we make the data interoperable. And that really means using those control vocabularies that we're constructing and taking the data and putting the PIDs into the data. And that will deliver us a level 5 product. So now we're talking about how the control vocabularies and the data come together to achieve that. What does it really mean? You know, I've got dirty data on the left-hand side of this slide. And in the first column, there's a series of clinical study identifiers. One is a study code, one is an acronym that people use to describe the study because nobody remembers the D codes, and then there is a legacy code. What we want from a data perspective, we just want these standardized. So what we need to do is provide a service that allows people to submit those terms and just get back the pref label and the PID for those terms. And that's what we're asking them to do, is to just curate their data by looking up against the control vocabularies where they're present. And if they do that, they're going to create interoperability. And they will create interoperability irrespective of the technology that you then want to use that data in. So if we have PIDs, URIs in our data, we have fully disambiguated the meaning of that value. And I have absolute confidence that if I see the same PID in another data set, I can join those two things together. And that has huge benefits, whether I'm building a relational database, whether I'm putting the data into a labeled property graph, or whether I'm building an RDF graph, or whatever other esoteric use of the data you want to do. We are eliminating the biggest hurdle to the reuse and the recombination of that data. And you know, you can say 80% of data science is spent wrangling data. If we can reduce that by 40% by doing this, you know, that is a huge saving to our scientists. They can get on and do their experiments rather than just try to fix their data. So the control vocabularies and the model. We took a really early decision to create a separation between the two. Now, you'll see many ontologies in the life sciences area, which are a combination of the vocabularies that describe an object and the model that relationships between the class and the classes and the relationships between them. I think the top quadrant referred to this as classonomies, and we decided that we wanted to create a separation between them. So we create our reference model, which consists of is built in OWL, and it consists of the classes and the relationships between them and the attributes, data properties that are associated with it. And so on the right-hand side, you see by a specimen, and you see it represented by a single orange post-it note. And then on the left-hand side, you see that expanded into the full entity ontology, and you can see that there is a class, subclasses, there are a large number of green data attributes. Just so you know, we support the string version as well as the class version of everything, so that if there isn't a vocabulary present, we can still deal with the data. But you will see that on the right-hand side of that post-it, that box, there's a whole load of blue things. Each one of those corresponds to a control vocabulary that we've created to describe this class. So we build all of those control vocabularies using SCOS XL, as I described, and we define the relationship within the SCOS metadata, saying this refers to this class, and in the class in the OWL, it says the reverse, so that we can then plug these things back together. But we create this separation because it allows us to create services that are really just focused on that use case that people wanted, which was to do this. They don't need to know anything about the semantics to be able to do this. And if I want the rest of the engineering teams to do this, I want to make it as easy for them as possible. We've gone further, and this week my team have now created a very big wide table of all of the control vocabularies that we've produced in Snowflake as just the pref label, the PID, the pref label, and all the synonyms. So SQL engineers can just use this common table to just do a lookup and SQL query it and get their data back. It's about making it as easy as possible for them to consume this so that they will put all of these PIDs into their data. Because we all know that if we can get the PIDs into the data, it's going to solve this problem. If I don't have disambiguated data, when I map my data into the graph or into the relational database or whatever, I need to have some sort of mapping table, a set of instructions to tell my engineering team that this, it goes there, and is equivalent to this, and that's how they join together. We want to get away from that. And so what we've done is we started with our reference model. We identified the thing. We worked out how we were going to describe it with control vocabularies and put it back in, and then use those control vocabularies to update the data. But what you've, of course, done is effectively bake your reference model back into the data without anyone having to know about the reference model. And now, things just snap together because they all have PIDs and they all align and they're all consistent. All the namespaces map and we can join them together. So it's just like snapping Lego blocks together in the instruction set, and it's already built into the data. So what have we actually achieved by doing this? Well, I referred to the data mesh architecture, and that's really the diagram on the left-hand side here. And at the bottom, you've got your applications. And the middle blue boxes represent the platforms. So the platforms are aggregating the information from their applications into a common product, and then that common product is being shared back into our knowledge map. And so as we've moved from the application level, where everything is application-centric, that we then go to a data product-centric piece. But even in the data product, you'll see the purple box is clinical study, the concept of clinical study, and it appears across multiple platforms because data from those platforms are generated and then it needs to be combined back together again, and that's what is happening in the knowledge graph. So we've transformed ourselves from that application-centric to now representing the data in a data-centric, or maybe more correctly, in a science-centric fashion, and we're using the terms and the preferred labels of the scientists now in that data, so they can ask their questions and explore that information space. So this is bringing it all back together. Start with meaning. Start with identifying your things. Describe the things. Work with your subject matter experts to identify all the terms. Have a consistent URI strategy, and then make it easy for the scientists to incorporate that back into the data. Sorry, I said scientists. I should have said scientists, IT colleagues, anyone who's generating data or is curating data. And then that's going to make it a huge improvement in our reuse of the data. It's going to allow interoperability for whatever we want to do. But also, sneakily, we've now got it all aligned, and we've managed to get everyone else to do all of that hard work of cleaning up and harmonizing that data for us, and we can just plug it into the graph. So the take-home message is, we want to deliver information discovery capabilities. We want to go beyond a reverse index search. And that is what is required to allow us to evolve the science and the greater granularity that's associated with it. It creates new demands on our data, and if we're going to build these complex data structures, we're going to need librarians to help us do this. And maybe, I'm looking forward to the talks later on about LLMs. I'm hopeful that they're going to provide us another way to help navigate this space. Use common patterns, so standardize. Don't be overly proud of your cleverness. Just standardize it, right? Because it's the data at the end of the day that matters. So it's great, open source. It will get you moving quick, but it's better to spend your engineering expertise on working on the data than it is on the infrastructure. Work out how to blend the relational skill sets that you've got with the semantic skill sets. Be pragmatic. Do what you can with whatever skills you've got wherever you need to. And design for extensibility. So assume that things are going to change, that you haven't got it right, and that the new ideas are going to come forward. And then this is all based on driving that interoperability. So we invest in controlled vocabularies. We build these SCOS vocabularies that describe unique things. And we do it in a coordinated and organized fashion, so an editorial governance is required. And hide the semantics. because 80% of the organisation just don't care. But 80% of the organisation will do an awful lot of work for you, which will let you do the work. So I've managed to pass 60% of the wrangling onto the rest of my IT colleagues and scientists, and I can focus on the semantics and doing the thing that interests me. So this presentation is a summary and aggregation of an awful lot of work by an awful lot of other people, and I'm just the face presenting it in many cases here. So I just want to take a moment to recognise not just our internal people in my team, the DATEV and Integrate team, but all of our collaborators across AstraZeneca, but also the Pistoia Alliance and the FAIR implementation work stream within that we've worked with, and hats off to all my colleagues in that, in other pharmaceutical companies who have been so generous in sharing their ideas. And I think that was the last slide. So hopefully there's time for a few questions.
So, yeah, thank you, Ben, for this great keynote. Do you have questions? If you have questions, please go to a mic in the room in order to be able to, our stream users to hear you.
Yeah, thanks a lot. Great presentation indeed. So, imagine you're in a larger organization where people who already embrace these concepts like data product, data mesh, and all what you described. They don't come from the knowledge graph community, the semantic web community. You tell them use SCOS, use JSON-LD, and they say, we have our own way to do this. And imagine also this is a large community, much smaller than the one embracing knowledge graph stack. How do you bring them on board?
We're bringing, so I come from a large organisation, we're 70,000 people. We've got a pharmaceutical companies, effectively 3 businesses. There's an R&D business, there's a manufacturing business, and there's a sales business. I sit in R&D, so I can influence R&D. We really asked, what is it they're trying to do? What is their pain? And we all know the pain, and it's, I've got this data set, I don't know where it's come from, I don't know what it is, there should have been a data dictionary with this, there wasn't a data dictionary. Is this column really the same as the column in this one? That's the pain that people have. So how do we tackle that? And that's what we focus on. And we don't talk about building SCOS vocabularies, we talk about building vocabularies to enable them to relieve that pain. So we hide all of these things about JSON. It might be really clever if we said, oh yeah, we'll produce all of our data in JSON-LD format, but it doesn't really matter. If they want to produce it as a CSV file, where one of the columns contains the PID, then we're probably pretty good anyway, right? So the answer is not to hammer on about the things that we care about, talk about the things that they care about, and say, just do it in the way you want to. Because if they all have PIDs in all of the data, I've got lovely tools like Accenture's corporate memory, which will let me take that data and just transform it to RDF from whatever source it needs to be. So let's not say you've got to work like this. Work like you want to do, but include this value in there. Yeah. There is a slightly more nuanced aspect around the interoperability piece. This comes from Martin Romecker at Roche, who makes the really valid point that there are actually, we refer to it as relaxed and strict FAIR, or interoperability. So relaxed interoperability says, ensure the terms that you use to describe that concept are included as alternative labels in the vocabulary. And that allows us to deal with scenarios where we might be dealing with a SaaS service where we can't add another column in to hold the PID. They can achieve relaxed FAIR by making sure that the terms that they're using to describe the thing are included in the vocabulary, so you then have the interoperability. It's a 2-step process because you have to look it up to get what the PID is, but at least it's there and you have confidence in it. That does require you to produce a data dictionary, which you should be producing anyway, that makes that statement. And the other one is the strict FAIR, where you include the PIDs in your data, in which case you're all good to go and you have machine readability as well. So focus on their pain, and they don't care about the graph, and they don't need to know about the graph. They just want to know that, can I join my data together? And that's enough to push it through in our experience so far.
Yeah, great. Thanks a lot. Yeah.
You have a question, Hans-Christian?
Well, yeah, I actually wrote down 2 questions, so sorry, my voice is a little bit funny, but I think it's interesting to also contextualize for the people that are not in the life science or biotech industry, why you got so much leeway from your board and so much money, to build this beautiful thing. Because obviously it's a multi-year effort, and there could be concerns of the cost. And do you see the end of the tunnel at some stage? And why? Does your board support this? Why is this so important for your entire industry? Why is the Pistoria Alliance into this for everybody in this industry? Why is that so relevant? I think that something that didn't really come across so well yet.
Yeah, I didn't. You're right, Chris. I didn't feel that aspect in. I think I'm very lucky. Okay, I've been doing this for a good 20 years in this space, and landing at AstraZeneca really landed me in a position where the coalition of forces all came together at the same time. There was a whole load of interest in doing data science and investing in data scientists, and we got that investment in the need to organise our data. I don't think I'm giving anything away when I say that we hire a lot of colleagues from the EBI in Cambridge, so the European Bioinformatics Institute, which is a big proponent of building linked data and has been one of the big enablers in the life sciences space. So we get these colleagues coming in, and they come in and they say, I'm going to be in a company and all the data's going to be really well organised and I can do really exciting things. And they come in and they say, this is even worse than the academic data. And it's true, because the whole industry, the whole thing are driven around submissions for your drug to get to market. And that's what it's driven for. And they don't design anything for reuse. And we're trying to re-engineer reuse into this. So the desire to have the data science and the recognition that we had to do something about our data was the driver. And we, back in 2018, we had a goal that said, at the board level, 80% of the data in AstraZeneca will be FAIR by 2025. That has quietly been dropped and hidden, but it created the momentum to do this. And the therapeutic areas, so the business side, the actual science teams and organisation, decided that if they were going to do this, they would invest in creating a group within their own thing, so not in IT, called the Data Office, that would be responsible for dealing with things like compliance issues. So, when we want to reuse our clinical data, we've got to ensure we're compliant with the informed consent of the patients that participated. So there's aspects of it. Trust frameworks. So, understanding, what are the critical pieces of data that we're generating, that they're able to be reported to help drive the standards for clinical data, et cetera, et cetera. And also building data services to try and help clean up the data, and that's where we landed. And I'm very lucky that Matthew Wooddock, who's my boss, effectively acts as a patron. And he's the expert that goes out there, and he has that talent for surfing the budgetary wave and protects us. And as long as we're still doing what he believes in, he gives us that largesse to actually get it done. So I'm very lucky of where I've landed, and it's probably a very unique situation in AstraZeneca.
Okay, thank you, Ben, and maybe I can add a few cents on this, because I think what makes me proud, in working with you guys, is at the end of the day, I think we're, as a society, we're at a point where creating new drugs is so expensive now, right, that we're looking at billions of dollars for a new product, and that again narrows down the scope of focus of these pharma companies, because you can only research products for large niches, basically, right? So I don't know, we know 40,000 diseases, I think, and we have products for 2,000 or something like that. And so 38,000 diseases are not being researched, basically, because the business case isn't there, because the cost is so high. So what excites me about this case is that if we can reduce, or increase the productivity of your scientists, and you say from, give them another 40%, because they don't spend 80% of their time, but only 40% of their time data researching, will make them more productive. And if you look at the greater scheme and you can say, okay, instead of 2 billion, take 40% out, the product comes to market faster, more reliable, higher quality, patient safety, and all those things. From a meta area, this is really relevant for all of our lives and the loved ones that you have, because we need to find a way to make life science and bioscience more productive in the future. And this is really the best role model globally. That's why this presentation is so relevant. AstraZeneca is the thought leader in this industry, and the work that Ben has done is a lighthouse, and we're together in the Pistoia Alliance. I don't know, it's more than 30 pharma companies in there. They're all following his footsteps. He's a role model here. So, say thank you to him when you leave the room, because the work they're doing is saving lives in the future. So thank you, Ben.
I will say, I'm just... Thank you very much, Chris, but I must give credit to the team in the FAIR implementation team, and Martin Romecker is my role model, and I'm doing a lot of following the great work that he did there. So we share ideas in that collaborative fashion to help us all move forward, and that's the point of Pistoia. And I will say that, Chris, your point of could be said, Ben, but you're creating FAIR for AstraZeneca. How is this fair with Roche or with rare diseases, or NGOs and those sorts of things? You're absolutely right. What we now need to do, and what we're now working on in Pistoia, is trying to agree that common interoperability. So what public vocabularies can we all sign up and say, we will include these identifiers in our data, so that we can have interoperability between these islands of FAIR that we've created within our companies, between CROs, between universities, between NGOs.
Well, Ben, you're dishing this up for me. Thank you for teeing this up for me, because I think another one that we get when we talk to clients and we talk about knowledge graphs in this technology, obviously there is a lot of debate about open source software. And I think what I heard you say in the presentation, I think that's really cool, is that you're suggesting not to get entangled in tool development and focus on, scaling value, right? So collaborating with others who already have ontologies, work on that, bringing them in, creating value in your organization, focus on your customers in the organization, and creating value for those customers. Don't get entangled into building software, because software is there already. And maybe if you can say a few words, obviously, I'm saying this all the time, customers just don't want to listen, but maybe they'll listen to you. So I like to hear that anyway. So.
Yeah, so thank you, Chris. The data is everything. Let's remember the data is everything. Let's put as much resources into the data and getting the data fair. That's where the value is. It's not in being clever enough to be able to combine open source tool with A and B and get them to work together. Let's just get away from that. Let's just move to this place. And we're seeing the market now with companies like Accenture being able to allow us to focus on the data. And that's where the value is.
Okay, thank you very much. We are not on schedule anymore, so that coffee break now is until 10:30. Outside, it's aligned with the other events on the Data Week, so we have now 20 minutes break and start with the first session on knowledge graphs and large language models after that. Okay, thank you, Ben, again.
the LSWT session at the Data Week, now 2004. And I'm very glad that Gardner talked about a topic that is dear to my heart, and it's making knowledge graphs usable for the common folks, not only for the engineers, but for everyone. And last year, I urged you to take a look at the usability so your data lakes don't become data swamps where nobody can enjoy the data anymore. And I'm very happy that some of the topics were already mentioned. In this session, we are going to see how knowledge graphs and large language models can interact with each other, and if the problem of getting the usability out of complex knowledge graphs can be solved with large language models. Therefore, our first speaker from the Fraunhofer Institute of Applied Information Technology with the topic of KELLM, knowledge graph, knowledge enhanced LLMs, Abhishek Nageni. Please come to the stage. The stage is yours also.
Good morning, everyone, and thank you, Kirill, for the introduction. I guess you all are having a great time here. So let's kick off the session, and I hope you try to get something useful from my presentation. Just a short introduction. I am Abhishek, and today I'll be presenting the topic, the topic how knowledge graphs enhance the LLMs in applications. So everyone might have heard the term large language models. I think it's in fashion these days. So let's quickly go through what are large language models. So these are generalist agents which could perform a wide variety of tasks, such as question answering. The same model could do translation, and also the same model could write code for you. So if this model is so good, they could also have their own pitfalls. So the possible problems you could see on the left is the chatbot that was deployed by DPD. I think it's a service logistics company where it tries to troll its own the company that deployed it. And then in the middle you see the case of Air Canada, where the chatbot gave wrong information to the user, and hence the user did not have a nice experience, while the same time the Air Canada had to settle for a law case. And on the right you could see the cases where LLMs were used for legal cases, and it hallucinated by giving wrong information. So given these large language models, which are very effective and synthesize information in a very plausible manner, they have their own pitfalls. So we at Fraunhofer have been thinking on how to alleviate this problem, and we have come up with the solution of integrating large language models with knowledge graphs. So here, let's go, I guess, just a short introduction of what knowledge graph is. Knowledge graphs are just agile, and then they are just an heterogeneous collection of data sources. You could do reasoning with knowledge graphs. You could enhance search and also give recommendations, and also the knowledge graph helps in data governance and quality. So as I previously mentioned, we at Fraunhofer have been thinking about how KGs can alleviate the shortcomings of LLMs, where at the same times how LLMs can also alleviate the shortcomings of KG. And here we are focusing on 4 basic research questions. The first research question is how can we automatically construct knowledge graphs. The second research question is how KGs can be used for retrieval augmented generation. The third research question is why fine-tuning LLMs with KGs would be beneficial. And the fourth, which is an interesting question, is for knowledge-intensive agents, how knowledge graphs could be useful. And now I will talk about each of these topics in detail. So let's go to the first research question, which is how can we automatically have knowledge graph construction by using large language models. So automatic construction of knowledge graphs is a painstaking process, and it is a very laborious process. And thus, in the research communities, there have been works which tries to use LLMs for automatically generating knowledge graphs. But the problem is that these knowledge graphs methods are generally customized to specific KGs, and they are constrained by the underlying knowledge LLMs, and hence they are not generalized enough. So we aim to have a generic model which could work irrespective of the underlying LLMs or irrespective of the underlying KGs. Just in brief, KG construction consists of 3 steps. The first is entity discovery, the second is coreference resolution, and the third is relation extraction. So here we did a research where we try to decouple the knowledge graph from the extracting phase. So in the first phase, we have the ontology, the recommendations that the knowledge graph generally needs to follow, and you also have the associated text from which you want to extract the information. This is then passed to a large language model, which first extracts an intermediate knowledge graph. But the intermediate knowledge graph is not complete because it would have missing information or it could have the wrong relation. So what we try to come up with is a self-correction component where, given the intermediate knowledge graph, we iteratively improve the knowledge graph. It could be by eliminating the nodes or by imposing the right ontology or by adding the right relation. And after a couple of iterations, you could get the final knowledge graph. So here is an example of our approach where on the left you could see an ODRL ontology, on the top right you could see the associated text, and on the bottom right you could see the extracted knowledge graph with the specified ontology. The next research question is retrieval augmented generation with the help of knowledge graphs. Here the motivation is traditional methods of question answering generally rely on the weights of the LLMs, and hence which is black box in nature. In retrieval augmented generation model, the aim is to first retrieve the correct information and pass to the LLM for actually synthesizing the information. So here it basically consists of 2 steps. One is the retrieval and one is the generation. So at each step we try to see if KGs could be beneficial, and we try to enhance each of these steps through using the KG. So for query augmentation, we could use KGs. So it could be the case like before giving the query, it could be the case that the query is not actually has the enough context for the deep learning model to actually get the enriched embedding. So we could add relevant information using the knowledge graph. The second step could also be, if you already have a knowledge graph, is it even possible to directly converse with the knowledge graph in natural language? And we also did some research on how we could do that. And on the third step is answer augmentation. It could be the case that the generated answer does not have the enough information, and you could also use knowledge graphs to enrich the final answer. So here I'll talk about a specific sub-case, which is how could we converse knowledge graphs with natural language. So the motivation why we should do this is because writing formal queries for knowledge graphs is challenging for non-experts, and it needs to have a specific grasp of the query syntax and also the associated entity relationship. So on the right you see the natural language query, who was the cast member of Titanic and born in LA. Here the method, what we try to do is first extract the entities from the text, which could be Titanic and LA in this case, and ground it to the KG. And the next step is use a prompting method to convert this into intermediate query using the entities and the natural language query. And the third step, as we previously did, was also to employ a self-correction method which could generate this final query which could be executed. So the third research question is why fine-tuning with knowledge graph is LLMs with knowledge graph is necessary. Here we see that the LLMs generally have the drawbacks that they do not have the right factual knowledge, they generally hallucinate, and they also lack interpretability. So if we do fine-tuning of these models by KGs, then we could anchor the LLMs with a knowledge source, and using that, they could gain a solid foundation which could effectively mitigate all these problems. Additionally, it also allows to seamlessly integrate enterprise data with LLMs. That is, knowledge graphs allows the use of ontological reasoning by integrating factual knowledge with the formal specified business awareness, which could be encoded as ontology. And in the third case, you could also have multi-hop reasoning, which is also called chain of reasoning. So on the right, you could see a question, which this question is very complex, and the question could actually be broken down into multiple questions. Now, if you have a knowledge graph, you could query each of the subparts of this query. The knowledge graph retrieve the associated sub-knowledge graph and do multi-hop reasoning to get to the final answer. And the last research question that we try to do is how can we enhance the knowledge-intensive work using agents by knowledge graphs. So what does this actually mean? So basically, what are knowledge works? So knowledge graphs works are actually very extensive, and the information is weakly structured. Knowledge work often has implicit or unstructured text, and it is very laborious process. So you always need to invest a lot of manpower, resources, and timings. So the challenges are generally most of these skilled workers are always in shortage, and this leads to low efficacy and also incurs high cost. And also classical automation process can only automate a fraction of these steps. In an ideal world, you could go beyond the labor market where you could fully automate the knowledge work. So you could consider a simple example where you have this interface and you want to write a research question on the topic of knowledge graphs on retrieval augmented large language model. So these agents would interact with themselves, and let's say if you click on finish work, it could generate all the associated research paper for you. But you could also do in a step-by-step manner where you could decide on what part of the process you want the agents to work on, and also give your input in the process. So, but we have not discussed what are autonomous agents. So the autonomous agents was generally coined by Mays in 1995, which says that they are computational systems that work in dynamic environment, and they do their set of goals and accomplish their tasks. So you could always ask a question, why you have LLM-based agents? So you could look at by the help of example where, for example, if you have an earnings call and you ask like a company X the total revenue, this could be answered by a retrieval augmented model in a one short step. But for example, if you have a very complex query, for example, give the 3 takeaways of the Q2 earnings by FY23 and focus on the technological modes. This question is, to answer this question, you need to do multiple steps, which is reasoning, planning, memory. And at each step, you could use knowledge graphs. So on the bottom right, you could see that agents generally have a 4-step process, which is profile, memory, planning, and action. So for profile, you could store all the agent information in the form of knowledge graphs. And for memory and planning, you could enrich long-term information with knowledge graphs. And for actions, you could also use knowledge graph, for example, the tree of the knowledge graph, and come up with the right tool for the agents to use. So I would also like to give a short demo of the work that we are trying to do using knowledge graphs at Fraunhofer. So this is a BAföG chatbot where you could, I think so it's not playing for some reason. Yeah, but you could actually converse with the BAföG chatbot and get your specified query answered. So this is my contact, and yeah, I'm open to questions.
Thank you, Abhishek. So, as always, are there any questions from the audience? If you have any questions, I will urge you to go to one of the microphones in the room so the people in the stream can also enjoy your question. If there are none, Abhishek, I have one.
Yeah, sure.
How long did you have to train your models? How many energy did you have to invest, like not
So
energy, but manpower to make it good?
So basically, the game is of just fine-tuning the model. So you generally have open source models which you could use right off the shelves. So what you have to decide is actually the data, how you want to structure the data, the amount of data that would actually be required, and also the associated techniques. So you have efficient techniques like LoRa and QLoRa, which requires significant amounts of less computational power. So it depends on the type of method that you do. I think there are, recently you have models which you could just train it on your personal laptop as well. So long are the days where you need thousands of GPUs to train it. I mean, you could fine tune it, but to train you obviously need large GPUs.
So doing something like this is feasible for normal people?
Yes, you could do it now. So it depends if you have the right data, you could fine tune a model on your personal laptop as well.
Yes. Thank you.
Yeah, sure. Thank you.
If nobody else has another question, that's it. Thanks. Abhishek. Oh, there's one. There's one. Yes. Can you please go up? No, can you please go up to the microphone?
For training your data model, or for creating rather more your knowledge graph, what kind of data you would use? Just a simple Excel or JSON?
So the training of it depends on the, so you could it's not necessary. So for example, you could change one data source to other data source. It depends on how, so basically it depends on the model and how you want to augment. So for example, you could use the knowledge graph, and now you could sequentialize the knowledge graph by doing some amount of embedding, where you could actually store the structure of the knowledge graph of the graph, and then you give it to the large language model. So there are work which tries to use transformers and knowledge graphs, and they combine them together to do a joint reasoning. So you could do it in any format. So the format of the data is not the limitation here.
Thanks.
So that's all. Sorry. No. We have to go to the next speaker. Sorry. So thanks, Abhishek.
Yeah, thank you.
Next up is a dear colleague of mine. He's a long-term researcher in the field of semantic web. He is associated with Infi and also with DBpedia, and has worked for the AKSW for a long time. Please welcome to the stage Johannes Frey and his talk, How well can LLMs talk with your knowledge graph?
Thank you very much. Today I would like to give you some overview, or also some little knowledge nuggets into our effort, which was officially or initially introduced by Lars Peter, benchmarking the abilities of large language models for RDF knowledge engineering related tasks. As the title suggests, in this topic we focus on the aspect of how well they can chat with knowledge graphs. I think in the previous talk it was already presented very well that there are several advantages in combining the two of them together. So LLMs can benefit from more recent data for long tail or private data, and they even especially can look up very precise information, like for example DOI of a paper and something like this. But also I think the previous talk showed very much that you can use LLMs in all these different aspects of knowledge engineering tasks, like extraction, mapping generation, ontology matching, and so on and so forth. So the question we ask ourselves is, when we want to build such applications, how do we combine them together? And so we said, okay, we need LLMs deal with language, so we need some kind of interface language which can deal as input-output interface between the two of them. And the intuitive choice we had was using Turtle and SPARQL. Of course, we did some experiments, hands-on experiments in the beginning, which we showed on the last data week. But in the scope of this talk, we focus on these two representations. And we have the hypothesis that these two formats are somehow a natural way of encoding these facts and relationships in knowledge graphs using these SPO style. Then they're well standardized and lots of examples exist on the web. And as such, we have the theory that there's enough data, training data, that's incorporated in the large language models already. So just to clarify this, we just use the LLMs as they are. We don't do any fine-tuning. We just measure the native capabilities in the scope of this talk. So how do we do this? We started this initiative, this collaborative initiative between different projects from INFI to build up an automated assessment framework, which has to focus on measuring different knowledge engineering related capabilities of these LLMs. And the architecture is quite straightforward. So we have a query generator which just generates prompts based on our tasks, and then we evaluate the answers, and we have different connectors integrated for the different commercial models like Claude, OpenAI, Gemini, but we also included GPT-4All, which is like a common tool to leverage smaller large language models which you can run locally and which are open sourced. At this current stage, we have 6 different tasks. 5 of them try to assess turtle skills, and 1 is focused on SPARQL specifically. And the tasks in general, they can be like static tasks. They just deal with 1 query, but they can also be scalable. That means they can scale in problem size. And we also have, of course, instant-based tasks, which can change the query prompt based on some external variables. Unfortunately, I don't have the time to go into all these tests in detail, so I just made this kind of overview slide where you can see that we try to assess different skills of the LLMs at different levels of complexity. So one task, T1 starts rather simple, so we give it the turtle file and say, hey, let's find a connection between 2 nodes. We require them to find in the prompt. So this is a rather easy task with regard to turtle reading, but there's no writing involved. But I think we consider there's graph understanding at a severe level required to understand all the transitions via blank nodes and to classes, and then from classes back to properties, and so on and so forth. The other task is the other way around, so we ask it to find syntax errors in an erroneous turtle file to find out how well they actually understand the grammar of the turtle syntax. The third one is a generative task, so we ask it to generate an example knowledge graph with persons contained in it, and we define some requirements about the relationships between these 2 persons, and then can also do evaluation on this. Task number 4, I will go into more detail in the next step. The idea is that we identify the most known person here. Then we have another task which is with regard to this knowledge extraction, and basically the motivation of the project I'm involved with, that we want to extract data about 3D printers in a PDF fact sheet, which works quite well from the extraction part, that when it comes to modeling the RDF, we still have issues there which we want to measure in this task. And the last task is a SPARQL generation based on natural language input. To give you some context for the next slides, so we wrote several papers with regard to this topic, and the setup is more or less the same. So but the models are varying. So for the static task, we perform 20 iterations each, and for the scalable tasks, we have also 20 iterations each per problem size. But we scale over 8 different problem sizes, and the framework is designed in that way that we can define a byte limit, and then the task tries to identify the number of entities, for example, with regard to this person task. So in this example, if you say, okay, our byte size is 1000, it generates 6 person nodes with the corresponding relationships between them. And in the case of 8000, which is the largest step size for this setup, it generates 76 persons. So why did I pick this this task? So first of all, it's interesting to see if you want to retrieve the data from a knowledge graph. You can either do it, for example, via SPARQL, or you can do it via Turtle, or you just generate text from the knowledge graph. As I said, we want to keep it as native as possible between the two worlds. So that's why we use SPARQL, but I specifically picked this example here because it was actually quite a fortunate situation. There's a little glitch in the generation of the initial experiment task, which showed a very interesting picture. So we can see we have different models here, and each model has its own color, and we can see that for the smallest size of 6 persons, there's something severely different from all the other sizes. And so let's have a look at what we are actually trying to find out here. So we have this graph with 6 nodes, and every node has 2 friendship connections to the next node, but there's one exception. This node number 1 has an additional one to node number 4. And the idea is, the task is now to find the person who is most known, so who has the most incoming FOV connections. And as you can see, there seems to be confusion here in this case, because there's exactly the same number of edges from number 1 to other nodes. So 3 FOV edges are outgoing. And for number 4, there are 3 incoming edges. So the hypothesis we had in this is that there's a problem with the direction. So the graph model, the LLM doesn't understand this graph model, that there's a directed graph. And this is quite important for us. But if you have a look at the larger nodes, you can see, because of this glitch, which, well, in the generation of these edges, you can see in the larger sizes, we have more incoming edges for this specific node who is known by the most persons. And as such, there's confusion is not possible anymore, because the number with the highest incoming links is also in general the entity with the highest in and outgoing links in total. And yeah, in another paper we also try to find out, because there's one thing I forgot to say. There's one model, which is Vituna, which is an open source, rather small model, and we saw, okay, what's going on here? Why is it so good and the others are so bad? So we try to find out whether there's a pattern in this. And the funny thing is, we could see for all the tested GPT-3 models, they were still struggling with this issue, and also GPT-4 model. And the first model who kind of perfectly found out the correct answer consistently was the November version of GPT-4. And we also had a little deep dive into these Claude models. And here we also found that none of the Claude models tested at that time, so 1.3 to 2.1, also didn't succeed in this task. But we could also see that the actually supposed weaker models kind of did a better job here. So this was also surprising to us, but we also saw that it sometimes is related to how it answers to the request. So we have some output requirements in order to pass the answers, which is reasonable, right? If you want to integrate code and want to use the LLM from the code side, you have to have some definition how you want to pass the answer. And we saw that the newer models, especially the more capable ones, they're very talky. So they say a lot of things and they don't keep to these requirements anymore. Yeah, so coming back, so this is one way to go. You just read the turtle directly. The other way is you ask a query and try to answer the information demand with the SPARQL query directly. So we also set up a little task here. Here we use the LC quad benchmark, which has a natural query and then a gold SPARQL query. And then we provided this natural query in the task, and we gave all the identifiers which are necessary to create the SPARQL query from this gold query, such that we don't assume the model to know the knowledge, the schema and the identities of the knowledge graph, because that's an unfeasible requirement, for example, for Wikidata to know all the entities. Yeah, and as a result, we had the problem that Claude was severely struggling. So all the versions, I think there were only 2 instances where it delivered a correct answer. The other results were none at this time. But for the GPT versions, we saw that they're an interesting trend. So the oldest GPT version we could access, the one from March 23, was the best. And the other ones, there's a slight improvement trend, but they're still not as compatible as the oldest version. But for the newest ones, we see definitely much better results for SPARQL query generation. And yeah, also a significant advantage over the older GPT-3 models. Lars Peter also created a nightly result snapshot. It's a good thing about this automation. And you can see here the GPT-4 model is still in the same range, but Claude 3 is now, seems competitive. So I don't want to do any ranking at the moment because it's still ongoing research. You can see Claude 3 Opus seems to be a big leap in the next iteration. And Gemini, unfortunately, is not capable of dealing with SPARQL query generation. So to sum it up, fortunately, we have a trend that the latest state-of-the-art versions are doing better. They usually outperform the forerunners, but they have this tendency of giving extra information which we didn't require, which makes it tricky to act on the text. Yeah, and I didn't say this, but the GPT-4All models, the smaller models, they still struggle severely. So just working on the RDF or SPARQL directly seems not feasible at the moment without any fine-tuning. Small teaser, we also do RML mapping generation. So if you want to know more about this, just approach me in the break. That's one discussion point we're still thinking about. So how do we prevent the LLMs actually learning all our benchmark data sets? That's, yeah. If you have input for me, would be happy to discuss that with you. Thank you very much.
Thank you, Hannes, for that interesting talk. So first of all, are there any questions from the audience? None. Okay. So Hannes, can you tell me if people can contribute to that benchmark?
Sure. So
what kind of way?
I mean, you can, in several ways. You can. So first of all, everything is public on GitHub. So you can contribute to new tasks. You can contribute to evaluating your own setup. So we just, of course, the benchmark is intended to measure everything, not just the native capabilities, but you can also measure your fine-tuning, for example, towards it, right? So you can contribute more tasks, you can use it to evaluate your own setup, and yeah, so we have this idea of building a continuous evaluation platform where you have like model cards for every model, see what they're already capable of. So for which use case does it make sense to use a model, and maybe to fine-tune it for your specific use case. So if you want to collaborate on that, we're happy to collaborate.
And everything is on GitHub, right?
Yes.
Okay. So, any further questions from the audience? If none, thanks, Johannes, for an interesting talk. We will continue with our next speaker. She's associated with the Office of Statistics and Elections of Leipzig, and has now also, and was nominated as a professor of applied, of the University of Applied Science of Merseburg. Let's welcome Lisa Wenige with her talk, SPARQLing with AI. Well, there are some difficulties. I also know Lisa for quite some time. She was a dear colleague of mine. We were sharing offices back in the day, and we were missing you quite.
Yeah, so. Thanks for the invitation. I would like to talk a little bit about how to sparkle with AI, how to combine the two worlds. It was already mentioned between the fuzziness, system one, quick search, fuzzy search, and the other world of structured data, knowledge graph data, but also relational data. These are always these two balances, or these 2 points that have to be balanced when we try to search for new information or to process information. There's this famous paper, or received paper that nicely summarized the advantages of large language models and advantages of knowledge graphs. And we always have to balance these two aspects. There have always been approaches that tried to, for instance, in search, try to bring structured data, filtering options to search interfaces in faceted search, for example, and there are also recent approaches where we try to invoke functions, maybe from a chat interface, functions that then can query structured data, for example, query weather data, query, in this example, how many inhabitants are there currently. In Leipzig, for instance, that would be a function call, then the API or OpenAI, for example, decides when to invoke the function in order to incorporate more structured data into it. We've also heard it from our colleague from Fraunhofer. The other approach is to do the approach of retrieval-augmented generations. Then we have some documents, text-based documents, maybe a vector database, where we rank and retrieve interesting documents that are relevant for a query, and then enhance the prompt with the query results, with the most relevant documents. For example, how do I reset my smartphone settings and then search through a user manual and then bring it up and combine it with the prompt and then present the result to the user. So this we are always approaches that bring the data to the model, for the LLM model or other models. But it's also, I think, important maybe to move the models to the databases more, so that we can have some advantages. For instance, in terms of search and retrieval, we often have the problems when querying with SPARQL that we have 0 result sets, or that we don't know how to query the database, how to query the knowledge graph. So maybe when we can incorporate some models into a SPARQL query, we can increase recall, maybe also apply some personalized filtering options. And also, we've heard it in the keynote talk, bridge gaps in data model understanding. So some users don't know what is there in the database, I don't know the model. How can we overcome this a little bit? It's not to say everyone needs to learn SPARQL and then execute SPARQL with SPARQL functions, but maybe to bridge the gaps a little more, and maybe then also build an interface on top of a SPARQL engine that has some more functionalities with AI models. It is also applicable to machine learning operations, to reproduce machine learning tasks that extract structured data, process them, and then save the result to make it reproducible, maybe sometimes to make it more explainable, to re-execute these workflows kind of with a SPARQL query. And also to have maybe some more complicated workflows in the background that can be execute every time something changes, or from time to time do something. We already have some functions that are integrated. Some OpenAI functions, for instance, are integrated in Neo4j and the Cypher query language. There we can also send queries to the OpenAI API and then combine them with query results in SQL. We have a startup called PostgreSQL that combines SQL queries with machine learning models, with LLM querying, but also general machine learning models. And in SPARQL, there are already approaches, for instance, from Meta Factory, who combine knowledge graph embeddings or general embeddings for querying and for search. I would argue that maybe we should look a little bit more into it, maybe create some more functions and apply them for specific use cases. I would also argue that in the general setup, you always have some utility options that you need. Maybe how can I extract a subgraph from the knowledge base? And also, how can I extract information for an entity or for relationships? So you have utilities that are graph-specific and maybe also ranking aggregation functions that should be combined with the SPARQL engine. Then you would have application-specific functions that are dependent on the use case. I picked use case open data as I for some time worked in the context of open data. So maybe you would like to query your dataset catalog, query for similar datasets, get some recommendations, maybe add some dataset descriptions automatically, or maybe also write some text based on the data you extract from it. These are functions that are already implemented. You can also think of train and tune functions that can train embeddings, that can train classifiers, tune LLMs, and make also these, as I think of your benchmark generation framework, also integrated into such a framework. So this is an example that is example queries executed on the LeetCat catalog of the Leipzig Open Data portal, where we see how we can do that. Here we have a SPARQL function that gets some arguments, gets, for instance, a text argument, could also be an IRI, and then we have another argument, maybe JSON or JSON-LD, that gives some model-specific parameters to the function. So here it says, yes, please query all data sets, all traffic data sets. And the first query is without the SPARQL custom function. And the second query is with a SPARQL custom function, embedding function that integrates more words from a fast text embedding. And this leads to query expansions, to more results, and increase and recall. Also here we see, here I would have liked to get some dataset recommendations. And here it recommends similar data sets. Also to translate, for instance, certain descriptions. And we can also configure pipelines where we combine, for instance, embeddings. Here I would have liked to create some keyword descriptions for a data set to make it more findable, some keyword descriptions, and enhance these keyword descriptions which are extracted from the dataset description with more text-based, fast text embeddings in order to increase the result set and make it more interesting. I would also argue that sometimes it helps to maybe get some text generation task with few shot prompting from the setup. So it is interesting, for instance, in your dataset catalog or in your knowledge graph, we have some examples. For instance, here I would have liked to say to the model, give me some dataset descriptions, write a new text based on other examples, based on other dataset descriptions for certain titles. So give some training examples, some few shots, send these few shots to the LLM, and give me for a new title that does not yet have a dataset description, give me, please, the dataset descriptions. Another example is, and this is use case specific in this case, so this we have in each corporation or organizations, we have recurrent tasks that are dependent on data sets. For instance, every corporation has an annual report, or in this case, in the city of Leipzig, I notice every year there comes the first name statistics, or every year opening hours for special markets in the city are issued on the open data portal. These are CSV files stored on the platform, and with such a SPARQL query on the dataset catalog, I could query for the latest datasets and then execute in the background a workflow that, for instance, extracts the latest first name statistics, so give me the first 10 rows for this, the most used names, what are the most popular names, and then create, for instance, a Twitter feed for it. So here to make the most of the structured data that is available and combine it with the text generation task. Bring more automation. Yeah, this is also applicable to press releases which are dependent on current data sets. This could be another use case. And then we have another application example with my students. We are working on a travel bot, Telegram bot that can be used for traveling in the city of Leipzig, and we want to generate a travel audio guide for each site in the city. So there are maybe 100, 150 sites. We want to automate this task, and there's I don't know if you know her from the BBC, Philomena Krank, who does mockumentary style information. So history documentations with a twist, with a bit of humor, and we would like to generate some such travel information in mockumentary style. Yeah, we can do this when we apply, for instance, the LLM for text generation, but also enhance the text generation with a bit more factual knowledge, with knowledge graph. So we want to not only to make the LLM hallucinate or think of some random facts, but also to incorporate knowledge from DBpedia in this case. Yes, extract, for instance, for the Battle of Leipzig, Völkerschlachtdenkmal, extract all the factual knowledge from it as an entity graph, yes, as a graph with all its properties, as an entity with all its properties, and then send this graph, send this as a turtle file, send this to the LLM, and the LLM creates a story from this. You could also make this in other genres, for instance, make a story for children, short story, and then apply this. So we have advantage to have a template, a SPARQL template, with which we can choose some text generations, automate them, and only fine-tune bits and pieces once we need them. So this is our travel bot with the different information. So here we want sites information in Leipzig, and then the guest, the tourist, can type in some sites, in this case Thomaskirche, and then get some children's-based information generated.
Once upon a time, Max and Moritz, two mischievous boys from Germany, decided to explore the famous St. Thomas Church in Leipzig. The church...
So this is a story based in the style of Max and Moritz. Now comes our story about Völkerschlachtdenkmal, generated with DBpedia data and OpenAI. And this is mockumentary style. This is now selected.
So, we're talking about the Battle of Leipzig, or as the French and the Germans call it, a load of words that I won't even attempt to pronounce. It's also known as the Battle of the Nations, probably because it involved more countries than a UN meeting.
So this is an example, because we have maybe 100, 150 sites. We don't want to prompt or maybe also each time write a script and SPARQLing, and so this gets scrappy and messy. So it's better to have clear templates that we can use and then apply them for such generation task. So yeah, I think this was it. I would like to maybe inspire you that we can maybe combine SPARQL and open or AI functions a bit more for our use case. It's clear that we need interfaces on top of that, and maybe someday we are able to achieve also natural language to SPARQL, that it works properly. And for the custom functions, we could also maybe apply intent classification, combine this, and give a full circle so that we can more fruitfully combine the two words of search or text generation and factual knowledge. Yeah, thank you.
Thank you, Lisa. So, are there any questions from the audience? Thanks for the great talk, by the way. I also quite like that you mixed in arts in there. Okay, are there any questions? Yes, please come up to the mic.
Thank you for the very interesting talk. So I have actually two questions. So first of all, what happens if the user comes with some request which can't be handled by a function? So do you handle some unseen information needs, some unseen question, unseen intents? And the second question regarding your knowledge graph story function. What happens if you retrieve, I don't know, several thousands of triples and they had to learn for the stories? So do you do some re-ranking, some filtering and so on?
Yeah, this is a good question. Yeah, thank you. They are unsolved, I don't know. So intent classification, I didn't start experimentation with that. It would be interesting to see how that works. I think intent classification, if you don't have too much intents, it might be working in a closed domain use case. So this must not be a problem. I think maybe the bottleneck is natural language to SPARQL. And the handling of a lot of triples, this is true, yeah? You are absolutely right, this is a problem. I would argue that you cannot extract a whole graph, or even subgraphs can be problematic, but if you stick to the entity graph, so only the entities and the outgoing edges, for instance, yeah, the entity graph function can say, please only outgoing edges, no incoming edges, for instance. Yeah? You can only parameterize this in the function.
Thank you. Are there any? Yes, please.
Yes, just one question explicitly to the chatbot you showed with Telegram. So is there some code available on GitHub or something that other institutions could just use it for their own queries?
Well, it's really easy to implement. Telegram chatbots are really
easy,
I can provide them to you if you send me an email.
Yeah, I mean, if you have like the whole backend for like talking with the database, talking with the chatbot, and interacting with Telegram, that would be a nice sum up of it.
Yes, but this is not implemented. Only the SPARQL functions and the bot are implemented,
okay.
but not the interface,
okay, thank you.
Translation. But thank you.
We have time for one more question.
Yeah, thanks a lot for the great presentation. One remark is may make sense also to bring this to the attention of the RDF Star working group because we are also working on the next version of SPARQL. So happy also to chair a related issue, which is under discussion there. Another one is a question. If you thought of using what you proposed also in the realm of shackle, so to say, kind of semantic validation. So whereas, for example, a cross exact match, and when I want to have an LLM to validate if it's really an exact match, if you think that would be also a useful direction.
Yeah, great. Thank you for the proposal. I will look into it.
Well, thank you, Lisa. Next up, coming from SAP's AI unit, Chief Expert for Knowledge Graph and Semantic Technology. With his talk, that was also mentioned in the keynote, by the way, a challenge, RDF, property graphs, or both, how to make generative AI in the enterprise work with knowledge graphs. Dr. Felix Saseki.
Thanks a lot. Yeah, thank you. Great to be here. Thanks a lot. Great to be here again. And Yeah, we heard already this morning from Gardner that ideally you don't have to choose. I mean, they're all good motivations for both technology stacks. But the point I'm trying to make is these technologies are evolving, and especially RDF is now evolving. And some directions make this combination easier. Some directions make it not so easy. And I just want to make you aware of this discussion, which is currently happening in the W3C RDF Star Working Group, where also SAP is participating. And want to get your feedback, what you think, what a good direction could be. And also to say this discussion, as you will see in my presentation, is driven a lot by vendors. Amazon plays a huge role there. But I think it concerns really everybody. It concerns also people who create content, people who combine knowledge graphs with large language models. It contains also who do we educate in what language to work with large language models. So I think it has a lot of influence, even if you're not developing a database like Amazon is doing. So, I mean, this is just stating the obvious, like what previous people said before, with some other arguments. So there's Gardner, for example, saying in generative AI, their impact report, there are various technologies, and the time for knowledge graphs is now. The time that knowledge graphs really make an impact on generative AI is now. And this has a huge influence, of course, on use cases and investment and so on. So I think that's a good sign. Then the research paper, already it has been cited before, seminal paper came up last year, which shows a lot of direction with mutual benefit. Of course, here we have a lot of perspective, the benefit knowledge graphs get, but there's also the other way around. And there's lots of opportunities, which already Danny Vanditich highlighted in his received keynote at the Knowledge Graph conference last year. So you could say it's really the golden age. Also this session really makes this clear, lots of opportunities. At the same time, and that's the point I'm trying to make, now some decisions are made. What direction generative AI and knowledge graph should go? Should it go in the direction where RDF is the central means to combine both? Should it be in a direction where labeled property graphs are the central mean to combine both? Or are there ways to make this combination easier? And again, referencing the keynote from this morning, there are good reasons to combine both. You have data integration capabilities easier in RDF, you have analytics capabilities easier in LPG, but you need to be sure that this combination is really possible. And that's really tough because there are quite a few differences between the technology stack. And now our discussions ongoing, how we should continue. So should it be important that these technologies stack more aligned in the next version of RDF or not? That's one of the key, very general questions. How important is this middle ground here? So, or is it more important that RDF gets more powerful in various ways or not? So that's really the question I want to raise and to get your feedback. And also to highlight the reason why this question is important, just to give you some examples, what you see here is a screenshot from the well-known LangChain library used by many people working with generative AI. And this is the part of this library which shows how to work with graphs. And we have a section just highlighting graphs as a general piece of data to work with. Now, if you look more closely, I annotated this here with an L standing for LPG, with an R standing for RDF, and with an O for other graph models. So you see that there's really a huge uptake using LPG. And you could say it's fine. It's okay. You could say, well, we do data integration with RDF, and then we do generative AI with LPG. The point is now, more and more people come to the table. I have really every week one or two people coming to me internally and saying, I want to do something with generative AI. And I've seen this Neo4j thing. So how can I start? We said, well, maybe start thinking about data integration. And when I say, and when there's a path, and when there's a path, you can go to LPG. But the question is really, is this path where, in what direction RDF is going? Another example here, a well-known site in the large language model generative AI community, deep learning AI by Unternehmen. So they create a tutorial on retrieval augmented generation with knowledge graphs. So pattern we saw a lot in the presentation here in the session, a very common pattern to give factual knowledge to retrieval augmented generation processes, even beyond what you can achieve with a vector database only. So you see here it has a huge uptake. It's created together with Neo4j, and it doesn't mention RDF at all. So really in this community, in this generative AI community, the awareness really for what benefits RDF have, what role they play together with generative AI, and may be just in the workflow, the role of data integration followed by a property graph based when, for example, a reg step or a query generation step. The awareness is just not there. And the discussion, I mean, it's a public mailing list, the RDF R-star working group mailing list. So if you look into the archives, you will see even people saying the future relevance of RDF is at stake. So this is really, I think, a critical time, especially as you see how much is generative AI transformative. It transforms people learning about new technology. So people now going into graph technology learn property graph when they want to do generative AI. And vendors, Brian Thompson is from Amazon, they make technology decisions. So what you will also see in this discussions when you want to dive deep, just warning, it's a long mail thread, so you need some time for that. But they say, okay, there's also a way to enable queries across the graph stacks. That's of course where vendor-specific view their feature. But even if you are not a vendor, that will have a huge influence if you want to have workflows combining data produced, for example, via RDF, and then continuing to work with it in a property of graph realm. If you're not involved with W3C before, you may think, well, this is just a forum of people like Amazon and Google and whatsoever in large companies, but the voice really counts. So you will also see in the last 1 or 2 weeks, people from the community saying, hey, I just joined the mailing list. I see there's a discussion ongoing. So really it is important what your thoughts are here on these next directions. So now what this is all about technically. Technically, it's about a key capability which is a difference so far between property graphs and RDFs. In RDFs, you cannot easily make statements about statements, and that was a motivation to create the RDF star community report. And that report is the basis of the current standardization. And yeah, what this is about. So here you see a statement visualized. I visualized on purpose kind of a bit in the way people from an LPG background would visualize it. So in LPG terminology, there's a node A, there's an edge name, and there's a value Alice. So you would say it's a triple with a subject A, the property name, the value Alice. And in RDF star, you can use this as a basis to make further statements. What we introduce is a so-called quoted triple for further statements, where we have what's here shown in dotted lines, a reifier node. And a key concept to make this compatible with the basis of labeled property graphs is to say this node, what you see here, just appears just one time. So there's just one node which combines this RDF statement with the additional information you give here. So we add another triple, you could say, or another edge in property graph terminology, record it, and then another value with a date. So that's kind of an approach which was defined by the community group working on RDF star and which is now being discussed And this has some syntaxes also. So the syntax which is close to RDF, the so-called quote triple syntax, and then the syntax which is closer to the property graph wheel, what you see here below, the annotated triples. So now what this is all about is a proposal which is in discussion and which I want to show here. You see the statement I had on the previous slide, and now here a different statement with a different subject, or you could say a different node which starts the relation to another node in property graph terminology. And the proposal under discussion is what you see here. And yeah, just want to pause a second for you to digest this. So the idea here is mean to say you can give these additional triples, these statements about statements, you can reuse them across statements. You can say I identify such a reify node and you use this across multiple statements. So that's the discussion which is currently under, that's the proposal which is currently under discussion in the IDF STAR working group. And the key aspect you could say beneficial is less triples are needed in terms of storage. If you say, I want to express the same information when something has been recorded, I can do it for several triples. There's semantic explicitness, also how things relate together. But, and that's now the key point, the compatibility here is much worse to LPG. So there's no suitable interpretation. That's at least the position of several vendors in the group. That's also the position of colleagues in SAP. I talked to who are working in this area of knowledge graph tooling, although SAP doesn't have that kind of tooling yet in Westec. So that has really not a suitable interpretation. That's really the proposal under discussion. I know it's quite technical, but I think it really is, now a situation where really a lot of decisions are made which will influence this overall compatibility between labeled property graphs and RDF. So, yeah, I would very much like, there's not much time now for discussion, but yeah, hear your feedback now or also in the break, and also encourage you to raise your voice either in working group, or there's also a thread here. I put this as a shortened URL on LinkedIn, on tinyurl RDF-star direction. It was started by Lassi from Amazon, but you see a lot of people participating there and raising their thoughts. So yeah, please give your feedback on this and influence the further directions of RDF and generative AI. Thanks a lot.
Thank you for the interesting talk. Are there any questions from the audience? Yes, Nathanael.
Yes, so my question is, there are reified statements already in RDF, but I don't see full compatibility of RDF star with reified statements. And I think that most of the parts that RDF star tries to introduce are possible with reified statements already. But the argument for not using reified statements is we have more and more triples, which would bloat the graph, yeah. But I think this is just a matter of tool support. And on the other hand, RDF star brings a lot more volume to the serialization of RDF graphs, since you always have to repeat the statement which you're speaking about. And so a turtle serialization, if I want to have the provenance for a triple with a huge literal, I would have to repeat this literal several times. Yeah. So I don't really see the reason in RDF star. I think it's just a matter of tool support, and we lack this tool support for reified statements. So why shouldn't we put this power in bringing proper tool support for reified statements, and then have a still lightweight exchange format for the serialization?
Yeah. The answer is simply reified statements are even more far away from the LPG compatibility. Mm-hmm. So when you do a statement about a statement in LPG, this meta statement kind of does not have global visibility. That's indicated here by these dotted lines on the left. And that's already a difference from the original reification mechanisms. You create global identifiers in the graph, to which you can also add all kinds of further information. You can then group them also. You can write queries also which make use of a groupment. All great capabilities, but capabilities which do not map to an LPG model.
Yeah. Okay.
That's really the point. How much important is this LPG compatibility compared to this expressiveness we already would have with the existing reification mechanism or with this adapted reification mechanism of IDF star? That's really the basic question. How important is this for our community?
Yeah, so definitely I see this community aspect, and I definitely would love to see joint forces of the labeled graph property graph community and semantic web community. That's definitely the point, but I think that this really weakens the semantic web community because it introduces, as you said, they're not globally visible. It introduces blank nodes, and we already have huge problems with blank nodes. So why should we buy in this huge problem into our technology stack? So I think we should keep a simple stack, and we should somehow, reach out and have a common community and common technology, which is important to have common community. I see this, but I don't think that this is really the right way forward.
Okay, yeah, understand the feedback. I have a different position, but let's chat.
Sure.
Okay.
Thank you. So we still have one more.
Hi. You have in your multiple statements, you have two very similar statements, but I could also do different statements like describe a whole flight, like when I try to model I fly somewhere. So basically this is, if I reify the flight, the verb flight, to an entity right now, this would be an alternative. And first I like it, the multiple reified statements, and I think we can still model LPGs even with this because we can still do just one reified statement, but we can do most. So I'm like that more.
Yeah.
Yeah.
Thanks a lot for the feedback. Yeah.
Okay. There are no more questions. Thank you, Felix. Our next speaker is currently developing the UI for the Open Research Knowledge Graph, and he's coming from the Leibniz Information Center for Science and Technology, Hanover, or commonly known to most of us as TIB. I welcome Khaireddin Fafa. The stage is yours.
Yeah, thank you, Carol. I hope everyone hears me well. So my name is Khaireddin Farfar, and I am a web and UI software engineer at TAB. And today I will be presenting how we are intertwining machine learning and semantic web in open research knowledge graph. So to start, let's start with an introduction of the problem that we are addressing with ORKG. So as you know, scholarly communications are largely based on documents, such as PDF format of research articles. While this is suitable for human consumptions, they lack of machine actionability features. And this poses a problem for machine processing. So as a consequence, when we try to find relevant papers, it's always cumbersome with this growing number of published articles. So when we use knowledge graphs, we have the possibility to describe papers, and basically machine can understand the semantics and the content of these papers, and basically they can give us the ability to provide better support for finding relevant papers. As you can see in this example, we have a paper, description using knowledge graph, and the metadata of the paper is in gray, while the sum of its content is in red. Here, in this case, we see a sentence and its annotation using the discourse class. So having such structured data for papers has many benefits, but creating such knowledge graph is not straightforward. So broadly speaking, we have two approaches to create such knowledge graph for research papers. We have automatic techniques, such as when we use machine learnings, especially NLP techniques, but this currently is not sufficient. sufficiently accurate. But on the other hand, we have manual techniques, so we can hire like skilled workers to model this data or add this data to the knowledge graph. So here in ORKG, we are trying to mitigate the drawbacks of both techniques, and we try to intertwine machine learning and semantic web to create such knowledge graph. So let's have an overview of the system design that we are proposing. The first system design is the paper annotator. And as you can see in this overview, so the annotation interface is in the middle. I hope you see my cursor here. Okay, yeah. Yeah, in the middle we have the annotation interface. And on the left-hand side, you see the data entry use cases. And on the right-hand side, you see the data consumption use cases. So the overflow is as follows. So the user uploads his research paper in a PDF format, and basically we give him an interface where he can annotate the most important sentences in his paper, or the key sentences, and then we give him the ability to annotate those sentences based on their content, to annotate them using discourse element ontology. And at the end, using these annotations, we can create a knowledge graph. So in this tool, we have 3 components for machine assistance. We have the automatic sentence highlighting, where we try to automatically detect the key sentences in the paper. And we have also the max sentence per annotation. Here we try to encourage users to only select key instances and not like annotate full paragraphs. And the third component is the automatic class suggestions, where we try to suggest some classes from the discourse based on the content of the sentences. So in the interface, it looks like this. So we have like the paper in a PDF format where the user can select sentences, and we list the list of annotations on the left-hand side. And as you can see, also we give suggestions when the user select one of the sentences. The second component is the template recommendations. So templates are like specific domain entities descriptions, where we give domain experts in semantics and also in the problem in scope. We give him the tool to create templates using ontology lookup services to connect different predicates and classes. And basically then the UI would generate an input form for the research community to fill this form according to the described templates. And after we collect a gallery of templates, we train a model to inference papers that are potentially important for an uploaded paper. Yeah. And in more recent, let's see first the interface of the template recommendation. So this is the interface of editing a paper in ORKG. And as you can see on the right-hand side, we see the suggested templates. And this paper basically is reporting the spread of COVID-19 virus, and the suggested template would be the basic reproduction number estimate. So the user can just use this template instead of looking it in the gallery. Yeah. So in more recent search, we developed these smart suggestions where we use LLMs. So basically the process is to transfer unstructured knowledge from traditional research papers to structured knowledge in ORKG. And for here we propose like to the LLM systems or ChatGTP to assist the users while creating this knowledge graph. Yeah, so we developed this, let's say, a button or a tooltip. So we gave it like a color palette distinctive to the rest of the AI. So when the user see this blue button, he can recognize this is maybe an assist system where it can help the user to generate the knowledge graph. So it contains an explanation, a short description for what is the input that we give to the LLM system, and also the list of suggestions below. There's also a help button, so that guides him to the help center. He can also reload the suggestion. Maybe he doesn't like the given suggestion by the LLM, and he can maybe reload or get different suggestions. And also we are interested to collect feedbacks from those suggested buttons. And basically, these feedbacks will help us to improve the prompt of the LLM that we are using for ChatGPT. Yeah, and I will now list some of the use cases of this button that we developed. So the first usage is for resource suggestions. So we can directly, from the abstract of papers, we can extract the research problem, and basically we use LLMs to extract this research problem resources from the abstract, and then we give it to the user. So he can directly, or he can quickly start creating the knowledge, extracted knowledge. Yeah. The second use case is for predicate suggestions. So here we try to suggest more predicates to the user. We just show it near the add property button, and we can give him a suggestion for adding properties depending on the already added properties. Another use case is the feedback on whether the literal should be a resource. So sometimes it's not always clear how, if we should create a resource or a literal when we start in the knowledge graph. So here we try to give the user an advice whether he should create a resource or just create a literal. Yeah. For another use case would be the feedback on resource structure. So here we try to collect like resource, atomic resource as possible. So in this case, we are using ChatGPT to provide like feedback on restructuring the resources. So in this example, as you can see, we have like the user wanted to create a resource called convenience sampling of 100 participants from Spain, and here the ChatGPT would suggest like to create different resources that describe like the sampling method and the number of participants and the location. Yeah, another use case for this button would be checking the predicate reusability. So when we create predicates in ORKG, we try to use generic label as soon as possible. And that would be like ChatGPT would check this reusability. Yeah, the last use case is the feedback on comparison description. So in ORKG, we are giving tools to compare different research papers in a tabular format, and basically we can publish this comparison and provide description. And here we are using LLMs to check the descriptiveness and the clearness of the description of each comparisons. And so we show it just on the description text area. Yeah, thank you for your attention.
Thank you for your talk.
Thank you.
So, once again to the audience, are there any questions from the audience? Please line up on the microphones. Yes, Nathanael.
Thank you very much for this nice talk. And so the smart suggestions feature, as I see it, it's like mainly a feature for manually creating a knowledge graph with such an autocomplete feature as I have it in like LibreOffice when I type and it suggests or type suggestions, typing suggestions when I write text and I have a long word and it says you may maybe want to speak about Rathaus when I write Rat. So is it like that and augmented by and supported by your language model and or by your AI?
No, so basically we are using it as like an expert in semantics, because as you can see, not all researchers are, they don't know like web semantics. So we use LLMs to assist them to add this knowledge or the knowledge of their papers in ORKG. And in order to do that, we are checking what they introduce to the ORKG, to the graph by using LLMs. So we are trying to assist them. Let's say here, don't create this label. Maybe use more generic label so it can be used by more users. Or maybe you can decompose this resource to different resources. So you can see here, like we are trying to improve the quality of the knowledge graph or the other input by using LLMs.
Okay, so it has suggestions and it also keeps the like quality in focus so that it the whole data model converge to some more common nodes.
Yes, exactly.
Okay, cool. Thank you very much.
Thank you.
So we have one more question from Ben.
Very fascinating talk. You know, the problem that you're solving is so common across lots of different industries. So when I was working with lawyers, you know, annotating precedents was one of those things. In the pharmaceutical industry, clinical studies, the protocols and the result sets, documents that are generated, we want to annotate those. So how generalizable is the approach that you've taken here to other knowledge areas?
So speaking of the UI, I think it can be used in many cases. Yeah, but because this is related to research papers, so we are saving this prompt and we're trying to improve them based on the feedbacks. So I think for each specific case, you can create a prompt and then you can ask the user for feedbacks for each specific case, and you can improve the prompt maybe to get a better result or a better final output of when you create the knowledge graph.
Okay, thank you.
Thank you.
Thank you. So I have still one more question, actually. Can this approach be used to also be integrated into your IDE? So given that you have already your formal class definitions or data structures defined that are using data models in your knowledge graph, that you get the suggestions while coding, which data models can be used directly if you're defining like something like a class, and then it says, okay, maybe you can reference directly a model from the knowledge graph, and so you can open up and use the knowledge graph as a foundational data model for all applications?
So currently we are using it on the editor interface, but not on the modeling interface, on the templates, if I say it correctly, according to our software. So in the templates, we are not using it yet for this purpose, but I think we can, if we improve the usability of this approach, if we see that it works well for the editing, we can improve, integrate it also on the level of the template editor.
Yeah, it was also a more general way for if you are producing software directly and you have a knowledge graph beneath it that you can directly reference, so not only for known.
Yeah, I think it can be used in any case. The most important thing is that is to have like a good LLM suggestions and to give the user to ignore these suggestions, because as we know, like LLMs can hallucinate, so it can suggest something that it's not correct, and you should get this directly to your knowledge graph. So maybe it needs a verification afterward, like when someone uses something from the LLM, maybe you need some mechanism to check this, the fact of this extracted knowledge by the LLM. So I think it can be extended or used in many cases. So, yeah.
Well, thank you.
Thank you.
Okay, since the last speaker is not able to join us today, we are back on schedule. Well, it was also planned beforehand, but yeah. The session will be closed shortly. The next up is lunch. I hope you enjoy lunch. And we will continue at 1 p.m. with knowledge graph use cases in industry. And to give you a trade secret of the data week, when lining up for lunch, you can use both sides. Yeah? So thank you for your attention. Enjoy lunch.
About knowledge graphs, use cases in industry. So at Leipzig Semantic Web Tag, we have the tradition to actually connect academia and industry. And in this session, we have 6 presenters from enterprises, companies that will give us some insights in how they apply knowledge graphs in their businesses. And we will start with Hans-Christian Brockmann. He's CEO of Essenza and also of Prox IT Consulting. And he will present us, or he will talk about, about a use case from Nokia, about Neurosymbolic AI, $1 billion opportunity. Welcome, Hans-Christian.
Thanks, everyone. Yeah, is it too loud? Should I be further back? Just let me know. It's exciting to be here, and I've been pushing for this because I think our industry also has to, and going back to the SAP part of the presentation, we need to also show the value of RDF and the capabilities of our technology of symbolic AI as a whole. And it's not only about building FAIR data layers it's also about actually transforming business decision making at scale. And we had the absolutely incredible opportunity, and I'm sorry that my friend Georg Geiger can't be here. He's in the hospital as far as I know, so hope he's getting better soon. We had the opportunity with Georg to work on a problem that started with a little spare parts challenge, how to get the right spare parts to a mobile network, moved on to the question of how can we get software to the mobile network or to a base station, and then in the end became $1 billion opportunity. And I have about 20 minutes, as much as I understand, so let me just rush through this. So the amazing thing about mobile networks is that they're basically the biggest organism that exists on this planet. So if you have the opportunity to optimize this, you're basically, this is a place where you can really come up with big figures. We didn't think about it when we started, but the consumption of mobile networks is about 242 terawatts of energy. And this is about $9 billion in the US market alone annually. This converts into 280,000 acres of deforestation. So we're talking about your CO2 footprint of a technology of your smartphone, right? And those were the opportunities that we didn't think of when we started the project. When we started the project, we just wanted to know what is a digital twin of an antenna, what's the spare part for the antenna, etc. So just briefly about Nokia, because a lot of people know Nokia from, and I'm using the slides at Georg's slide actually, people know Nokia from their mobile phones. They don't understand that Nokia, Ericsson, and Huawei basically have each a third of the global mobile network market, and all have sound and good business models. We often hear that Nokia, you still exist, yeah. An amazing company, but that's a different discussion. Transforming from a rubber boot company to a mobile network giant like this. But the problem that they were facing is, at the end of the day, in the software delivery, they had no visibility at all into what was going on in the network. They had no data backhaul from the network. They didn't have any centralized orchestration of the activities. They had no seamless sharing of data between the different business units. So even the spare parts people didn't talk to the software people, to the contracting people. You know, and then there was no business decision making on top of it. Even for the pricing of software products, it was difficult to figure out what the hell to do. And the breakthrough idea was to now centralize all these different elements, you know, that are about to manage mobile networks, right? To centralize all of them into one central digital twin. So the licensing, the entitlement management, the in-product analytics, and the delivery and update process into one platform that is powered by symbolic AI. Right? Now, this is actually a pretty difficult feat because the type of information that needs to be integrated lives in totally different systems. So you have these compliance management systems because some of this technology is, you know, under military grade equipment. So it's highly regulated what goes where and who can buy what, etc. You have cybersecurity dimensions to all of this because if mobile networks get hacked, you know, you can basically stop an entire nation from functioning. But you also have the commercial aspects of things, and interestingly, I don't want to divulge much, but on the commercial side, we found about 100 million of unbilled services. So that was kind of nice. Then, of course, the software library, so it's this firmware-software combination, hardware-firmware-software combination, so there's library software bills of materials, and since, you know, it's almost like a truck, each antenna is a project, right? So you have the base station with lots of antennas mounted on it, and basically not one single base station looks the same like the other, because over time you just add more and more and more. You know, you want more density here, you have more network density there, you just keep adding. And over time, it got a real big mess, and getting the software to each of those base stations was a problem. Then you had the master data issues, different applications again to be integrated. And the cool thing about the symbolic AI was that we didn't have to worry about the fact that all these applications had their own schema, right? We just built a semantic model, and all of a sudden, the Tayloristic mindset of this industry, you know, was overcome, and you can all of a sudden look at this in a holistic perspective, right? For the moment, the key initiative was to just build the software in this delivery platform. Currently, Nokia is saying it's about 30 million hourly business impact for them through this platform, so it's pretty critical. So since all the software packages that get pushed into the network come from here, and I think the whole application will migrate further and further to the edge so that we basically start owning the whole process all the way to the antenna over time. So, you know, but what's the success of all of this? I mean, we did manage to gather all this information, integrate all this information, fuse it with the data, eventually also integrate with real-time traffic data, right? What the effect was, of course, that we could really get real-time information and respond to that real-time information immediately. Updates to a base station in terms of software updates prior to this project took about 6 weeks. Now we're talking about updating software into thousands of antennas a minute. And that's why we have the $30 million hourly business impact, because we can do so much in 1 hour, right? So everything could be centralized, everything became seamless. And, you know, what's the business impact? Materialized business impact in operational savings is 300 million annually. So this is about saving round trips for spare parts that go to the construction site and where the spare part doesn't fit. You know, software not fitting, people having to go multiple times, of course, but also 100 million of those 300 are actually identified unbilled resources in the network. So, considering that the project probably cost about 5 million, it's pretty darn good business case, right? But the cool thing is really the impact on the energy consumption, because now we can power up and power down antennas, bandwidth even on channel level, right? So that we could save 25% of the energy consumption in the network, right? We have 20% performance gain, so we actually, from existing infrastructure, we can get more bandwidth for the clients. We, of course, create double-digit growth in the software business for Nokia. We have 97% less operating expenses in the process. And again, you know, we also have the innovation cycle drastically improved. At least on the Nokia side, a lot of this stuff also has to be coordinated with the network operators, and that takes time. So, but right now we are at 25% reduction, and that's a really big competitive impact for Nokia in their positioning against tough competition from China, I'd say, and Sweden. Yes, but we're helping the Swedes as well, right? So. Yeah, so I think I try to make this quick and dirty so you guys would have some time to ask questions about this. Again, thank you to Nokia and to Georg, for sticking with us going through this. This was a 5-year exercise. Thank you to everyone who was in this team. I think this may be one of the bigger achievements in my life, to be able to use our technology. We're all in this community. And we can move the needle to this degree with this type of technology. I mean, that should make us all very proud, but it should all make us very ambitious, because there's a lot of people that make a lot of loud noise, but they consume more energy, they cost more money, and I haven't seen them save any money yet. So I think we should be much more ambitious about what we can do and what our place should be in industry. Thank you.
Are there questions from your side? If so, Ben, use one.
Given you so thoroughly quizzed me, Chris, I feel I have to. Were there other? Those benefits are just amazing, right? And they really speak to when you can see what's happening, you can actually realise value. I'm interested in was there any additional value seen in Nokia about having to started to really make master data management and reference data management work to make this work, that they're propagating that out into other areas as well? Or is this still seen as an isolated case?
Well, don't want to say too much about the client itself, maybe? But I would say that large organizations are still tending to be in their Tayloristic mindset. So we are in one of their verticals, and the culture is not to speak with other verticals very much. So that's a little bit of a disappointment for us, but we take the good with the bad and the other way around.
We see the same, so,
But it's about telling the story, and funny enough, one time there will be a Nokia guy from a different department in here and say, why haven't we ever heard about this? Right? And we have that same in other clients, with Siemens or whatever, It's just keeping talking about it. And, if you guys keep telling your friends about this, maybe somebody knows somebody in Nokia, And that's what we see in other companies as well. And I think Bosch reported on this. If you reuse and repurpose this type of work, the next project is already 60% faster and cheaper. The third project is 80% faster. That's statistics from Bosch, right? Because of the reuse and the repurposing of the data integrations, so the data knowledge that was created and the business knowledge is also repurposable. And that makes, organizations so much more nimble and agile in innovation. That's really exciting, yeah.
Thank you.
Well, guys, thank you very much. I wish I could say I'd be around to chat, but you guys need to chat with Stefan or chat with Renee or Marcel, maybe. Thank you all for coming. I'll have to run to the airport to get to another meeting. Good being here, and hope to see you here next year as well. Thank you. With more industry science.
Thanks, Chris. Next speaker is Nikolai Krustev from Ontotext, the makers of GraphDB Triple Store. And he will show us some industrial knowledge graphs in actions. They deliver their technology to a lot of companies who work with knowledge graphs, and stage is yours.
Thank you. Hello, everybody. So I think essentially very well known in this field, and we're thankful that they invited us to this conference, and thank you to the organizers as well. A little bit about us. We are headquartered in Bulgaria, in Sofia. We've been around for about 20 years in this space, and we are growing rapidly in the last 5 years, dramatically. And we operate in many different verticals, infrastructure, manufacturing, life sciences, government, media. But what we are mostly well known for is GraphDB, which is our RDF database, and various services and consulting services that we do on top of that. Knowledge graphs have been around for quite some time, and I think it's important to understand that they're not, be-all and end-all. They're not the end goal of any project. They should facilitate work with various kinds of information and optimize the way corporations and governments leverage the abundance of data that they currently have. And I think it would have been nice if I just start with the link to Open Data Cloud, which would be very typical for a conference like that. But the way we see it is how we move from just having disparate data to actually going into wisdom. So there are a number of steps that we help our clients with to extract much more, to harmonize their data, to involve additional data sources to get most of what they already have, because it is a gold mine for themselves and untapped opportunity. I think, the sweet spot, of course, if you have a diverse database, if you have unstructured information as well, we can help work with that. Domain expertise, and knowledge graphs in general are flourishing in that setup. And most of you probably have seen Ben's presentation, which I'm sure was very insightful, and Chris as well. What currently is the big hype, of course, is LLMs. Well, I wouldn't go into this, but yeah, we have that. And this is the best interpretation of what ChatGPT could translate. If it's not correct, it's not my fault. But of course, if you ever tried using LLMs, you know all about hallucinations. And you know something else though. What is in a typical LLM is public. So everybody else will have exactly the same, unless you do, some very expensive stuff with it. And your competitive advantage is not with what's already out there and everybody else can use. Your competitive advantage is what you have internally. So knowledge graphs are actually even more crucial these days, because the way you organize your data, the way you combine it with the LLMs is actually what's going to give you an accelerated way to success. We have, elaborate charts and reference architectures about what we do and how we do it. I'll be happy to talk to you after this talk, because it's a rather short one. But I wanted to get into a few actual implementations, some use cases in several spaces. So one very interesting one comes from one of the largest automotive companies in Europe, where they used knowledge graphs to basically build a digital twin of their vehicles. There's plenty of ECUs in any modern vehicle, and they all suffer from the interoperability problems that everybody can think of. Different versions of firmware, different capabilities, different software and hardware functions that have to work in unison to ultimately deliver on specific functionality in the vehicle. So managing this complexity and understanding how you can update your vehicle with new functionality, if your 70-second ECU is in an old firmware, becomes challenging. So understanding the eligibility for you to get those new updates can be greatly improved if you have a complex ontology with some inferencing, and then work your process around that. Amazing project, multi-DC, so multiple data centers support this with GraphDB in a clustered fashion to deliver those services to the entire fleet of this car company. Another interesting example, cable manufacturing. You can consider this niche, but it's very reusable in other, it's basically a configuration system. So you would be amazed how much different types of cables there could be with their different signal qualities and purposes and material strength and expectations and different termination points. So this is basically a solver for when you're configuring a cable for a specific purpose. Of course, knowledge graphs can help with that, understanding the different fact sheets, the different materials. There's ontologies for all of those things that you can fuse together and leverage the inferencing capabilities to help you in the design and costing processes when you're building something like this. This was, again, a project that was using GraphDB and some of our consultancy services. Similar to a degree example, one of the top 3 Japanese car part makers is using GraphDB to optimize their specifications, requirements gathering, testing, again, leveraging knowledge graphs and different ontologies. This is just one of several examples that we have for this particular use case. All the other ones, unfortunately, I cannot talk about, but they all come from Germany. But it's been a very nice use case that drastically improved the quality of their work and their hit rates when they're working with this process. Apart from automotive and just pure manufacturing, we work with a number of transmission system operators, because knowledge graphs, if you consider what your electricity system is, it's basically a graph. So you can easily model that. There are amazing people that try to do that. Statnett is leading the way, the Norwegian company that we work with for quite some time. But this is also an interesting ecosystem, because especially in Europe, all the transmission system operators have to communicate with each other. And RDF is amazing for doing just that. So they would share their national grid models. There's a Europe combined model, and you would take this information and use it for many different purposes, understanding peaks and how you solve different problems, understanding production and usage and analytics and where you need additional capacities and things like that. So we are very active in the electricity space as well. There's an interesting demo that you can check for yourself. It's called Transparency Energy Knowledge Graph. That came as a result from the European project, where we take a lot of that information, RDFize it, and we show different production capabilities with geographical location, where exactly is this particular reactor, what kind it is, what are the balancing timelines and things like that. Feel free to check this out. Another very interesting thing that you can do with knowledge graphs is do building automation. And we have 2 amazing use cases. All of the big enterprises that create equipment for buildings at some point needed something to operate this equipment with. So GraphDB currently is being shipped and deployed to more than 15,000 different locations embedded with Johnson Controls Metasys. Schneider Electric EcoStruxure is using GraphDB, again, based on the brick schema ontology to do pretty much the same use case with a bit of a different business model. And it shows a lot of promise and enables functionality that was previously not there. But those were some very, very concrete ones. You can easily repurpose the same technology stack and reuse it for different kind of industries, which is why Ontotech has so many different verticals that we offer our services to. So let me tell you a very quick data story. So this is, I don't know, a conveyor belt that builds something. There are people that are very interested in creating digital twins of pretty much everything, and this is no exception. So all the different elements, all the different electrical components, all the different assemblies, you can model in a very detailed fashion and understand things like the yield of this conveyor belt, for example, and how to optimize that, predictive maintenance, how to optimize certain processes if you have the data. And you probably do have this data even today. So there are ways to harmonize this data, use knowledge graphs to get more out of this. And GraphDB, as in this reference architecture that I just quickly showed, is very much at the centerpiece of a lot of those use cases, because there's connectivity through to different other data sources or interfaces that you can leverage to have this in sync with your existing infrastructure. So what happens here? Well, a problem occurs, and you have all the sensor information aggregates used to do analytics with GraphDB, and you can identify exactly where the malfunction is. But who's going to solve this malfunction? You have a digital twin of the equipment, but then there are certain people and certain skill sets that are required to solve this issue. And then knowledge graphs can help with that. You can model your workforce, their capabilities, their skill sets, the things that they've worked previously on. There are ontologies to do that, like the ONET or ESCO, or some proprietary ones as well. So you can send the right person for the right job. This is helpful for any industry that relies on humans, which fortunately most of them do still. But what would be the missing piece? Well, this person might not be there. You need to understand geo information, and there's plenty of ways to do this. GeoNames is an easy way to understand exactly where something is. And then if this person is nearby, where is the team that's have to service this network tower that's somewhere? Do they have the right equipment for the job? Because for some of those activities, you need to have certain equipment. You can model this with a knowledge graph and understand what are the things that should be done to fix a particular problem, what is the equipment that is required, where it is geographically located, and ultimately deliver on the job. And this was extremely generic, but you can easily paint yourself a picture in your particular domain and vertical how knowledge graphs can be helpful. And we'll be very happy to discuss and figure out how we can assist you. And it's not only us. I want to thank Essenza for inviting us to this one. Some local presence is always nice. And with that, thank you, and I'll be happy to chat afterwards.
Yeah, thanks for the presentation. A little bit over time, but I guess we still have time for one question. If there is something from the audience. Frank?
Hi, thanks for the talk. And I would be interested in how you build the ontologies that you talked about. So when I saw like a 12-month project, so is it mainly you or mainly the customer, and on which basis? So do you reuse any existing resources, or do you build things from scratch, or where's the trade-off?
We always try, thanks for the question, we always try to reuse the state of the art. We have an exceptional team of data people, ontologists that first see what's out there if it's a new domain for us, and then it's a collaborative effort typically. So we consider ourselves as core semantic provider, and we also do fundamental semantic consulting, which means that we don't claim to be the top-notch experts in any particular field, but in collaboration and using our methodologies, we can extract everything that's needed from the domain expert and put it into good practice using semantic technologies.
Okay, thanks.
Thank you.
So our next speaker is Inga Klotzbach from Adorsis GmbH, and she will show us a use case from DATEV and how they use knowledge graphs to shape their data catalog. Welcome.
Okay, thanks. So hi, my name is Inga, and I'm currently working at Adorsis. Sorry, my voice is a bit, or my throat is a bit sore, so don't be surprised if I sound like Rod Stewart after a while. So, yeah, so what are we going to talk about today? So, connecting dots, how DATEV leverages knowledge graphs to shape its data product catalog. So, first of all, I will just go through the agenda. So, first of all, I will tell you something about DATEV, what DATEV actually does, and what they want to do with their data. And there is maybe a solution like called data products. But after that, I will tell you something about what is the actual goal they want to earn, and what the challenges are and the next steps we want to take to solve the challenges. And of course, the fifth point is questions and answers. So let us start. If you're not familiar with DATEV, DATEV is actually a software service provider with focus on tax consultancy and financial accounting. So it's quite an old company, I would say, from 1966. And it's actually one of the largest cooperatives in Germany. And as you can see here, it has also a lot of employees. But what does that mean? A lot of employees means also a lot of departments. A lot of departments means also a lot of data. And mostly it is something like if you have a big company, it's also a lot of data silos. So why is this a problem? You could imagine if you want to start a project in a company, you need data. And if you need the data, you have to ask the department, do you have the data that I actually need? And the department would probably say, nope, but why not ask this department? And as you can see, sometimes you are lucky and you get the data that you want, but mostly it's something like, okay, no, go to the next department. And this is really, really time consuming. And you could imagine in the industry, time is money, right? So this is like a whole iteration. So what wants DATEV actually want to do? DATEV wants to be able to make data-driven decisions. That's like the main goal. But it's not that easy. So how can we make this happen? Now I will tell you something about data products. Maybe you've heard it like in the first session, but what are data products actually? So as you can see here, it is something like data should be viewed as a product. So you have to imagine when selling products, we generally put effort in it, right? So we care actually about the data quality, and we want that you have also the responsibility for the data. But we have the same problem again. So what about findability, to actually find the data? So therefore is a solution that is called data catalog. In a company like, or what is a data catalog, first of all? A data catalog is something like a marketplace where you actually can find your data products. But in a company like DATEV, where personal data is the most valuable asset, it would be detrimental if everyone had access to the actual data. So the question is, what about data policy? There's also a solution for it that is called data contract. And this is nothing like an agreement between two parties with the assurance of being able to consume the data products. So similar like a purchase contract. Okay, now we have the data product, the data catalog, and the data contract. So how can we ensure that the data contract, for example, is right depending on our company policy, same as the quality of the data? Therefore, we actually need parameters to determine it. So, therefore, you have the data governance, and this is a really important aspect, especially like in huge companies or big companies, because data governance is something that encompasses guidelines, processes, and responsibilities to ensure the quality, security, and the integrity of data, especially in data products, contracts, and so on. So the 3 points that are really important are the people, the process, and the technology. For example, people, this is something like defining roles and responsibilities for those working with data. You have the processes with workflows to manage data within the organization. And you have the technology. So something like a data catalog is a technology to support data management. Although data governance creates the basis of trustworthy data, it is not enough on its own to make data-driven decisions. So why? Because this also requires context, and this is the actual bigger picture we want to integrate. So currently, we are on the part of the data layer, right? So we have the data, but the data has no information right now. So to get to the information layer, we need context. And the context we actually want to create with a semantic layer. And this is something we are currently building. So as you can see here, that's actually an architecture overview, what we want to do and what we are currently implementing. So as you can see, like on the second or the data lakes and so on, so you have your databases, but on top of that, you put the semantic layer. And what we are currently doing is the ontology management, right? So our current implementation, how we started it was we building standards and blueprints for ontologies. That means we have some use cases inside of the DATEV and also some applications. So just make little steps to get these standards actually in the whole ecological system of the DATEV. But furthermore, we are also identify which technical requirements do we actually need to operate with a semantic layer. So this is also a process we are currently working on. And how do we do this? Of course, we are building first prototypes. So as I said, we began to write ontologies for different use cases inside the DATEV and yeah, to transform into an actual knowledge graph. So of course, with work, there's also challenges with it. So the challenges that we are faced was the data governance and the semantic integration part. Especially with DATEV, the great emphasis on data privacy, which is really crucial, especially for personal data. For example, who's responsible for the data? Or simple use cases like how to actually write an ontology. Some processes like this are important to write down because there are a lot of people who are going to use it. And this also means raising awareness for the topic, right? I think a semantic layer is something really abstract, an abstract topic, and to bring everyone together and on the same page that everyone understands the same thing is really one of the challenging aspects. So yeah, that's what I wanted to really say. This is really important part, right? And the last one is, of course, the tool question. What suits the best for us? Of course, it's like an iteration process, but for this time, it's also really important, okay, can we use this tool or do we need another requirements that are actually needed? So I think that's all the main challenges that we are faced. But we are getting there. So what are next steps? First of all, we want to create more sensitivity for the topic. So we do trainings, we do workshops, presentations, as like here, and of course also communities, so that everybody wants, yes, I can see that, communities that everybody is engaged to the topic. We also convert more use cases also for the applications within the company, so that you have like, yeah, a standard, and we want to engage to do more standards to use the actual knowledge graph, because if you have use cases, you can do more information, and at the end you have a knowledge graph, right? So the last point is also getting advice from others, so that's why we're here actually. So if you have any questions to me, you can ask them, but if you don't, after that we can talk, because we have the questions, do you have any advice for us, or have you experienced similar cases? Maybe you have any advice for us how to do it better. So yeah, thank you, and yeah, that's all.
Thank you, Inga. Are there any questions from you? Marcel, can you please come to the microphone?
Hi, so you were writing about process description for building ontologies. So I wondered which roles or personas are meant to do the ontology building?
We think about, because we think about that the technical experts that are actually in the domains, so experts for financial accounting, they should do the ontologies, because they know what is really important for the structure of ontology, or for their ontology in their domain. So right now, we write the ontologies, but after that, the actual experts should do it, because we are not in the accounting, or in this accounting topic. So, so therefore, we need this process that everybody knows how to actually write an ontology for that. So, yeah.
So, actually, I challenge that this is a good idea to believe that everyone can build the technical artifacts of ontologies. So while I agree that it's super important to get the knowledge and the subject matter expertise from these people, it might be quite a stretch to assume that they build technical artifacts that you can use to run your knowledge graphs.
Sorry, I didn't understand what you said. So what we are doing is we use, for example, we use Metafactory to build our ontologies, and I think it's like a good user interface, so everybody can actually write an ontology, even like not a technical person. So
all the best.
Thank you. So also communication, I think, is therefore a key to success. So.
Any more questions? No? Okay, then thanks, Inga.
Thank you.
And as she said, so if you have any recommendations or any tips, hints, you will meet her at the coffee break, I guess. So our next speaker is Jennifer and Simone from a local football club, Rasenball Leipzig, or RB Leipzig, and they will show us how a modern data stack for commercial analytics in football looks like. Welcome.
Thank you very much. All right, so we will present how we approached setting up a data platform in a football club. It's a lot more basic than most of the topics we've heard so far. So bear with it. It's a good intro or a good insight on how to get started with data analytics and the potential advanced use cases that come from a setup like that. So just a very short introduction. This is Simone, my colleague. She is responsible for all the data analytics in the football club and responsible for defining and developing data products that sit on top of the data platform. My name is Jennifer and I'm a data engineer working in all engineering related topics in the data field in our club. And as I mentioned before, the goal of this presentation is to just show you how we got started in the data journey and what use cases or advanced use cases come out of that. As I said, knowledge graphs is a bit more distant for us, but the journey hopefully goes in that direction eventually. All right, so what have we built? We've built a data platform for a football club. How did we start that whole thing? It was important for us to have some guiding principles first when we started, and not to just build a stack, which is, contains a lot of buzzwords and is following the trends. So we said, okay, hey, let's have some guardrails in place, which we use to build the platform. So one is to have a code-first approach. Every component of our platform is in some way or form codified, and we use infrastructure as code, for instance, to make sure things are transparent and reproducible. And we also said the things that we do build, they need to be maintainable by multiple people. There is no point in having one person only that can operate this whole platform. The next thing is event-driven workflows that make sure that the data flow is consistent and has a very little manual interference or complicated orchestration in place. So ideally, when data comes in, the next step is triggered in order to flow or in order to support an end-to-end data flow that actually empowers analytics use cases. The next one is principle-driven architecture. So what we do is we do not look at, okay, hey, what are the shiniest tools out there that can support LLMs or support certain AI use cases. Rather, we tackle it the way that we look, okay, hey, what is actually the thing that we need? What is the thing that we might want to offer our fans? What is this thing that supports our business? And then based on that, we actually say, okay, hey, in order to realize this use case, we might need tool A, B, or C. Then we do have an open source strategy, so obviously a lot of the interesting technology is open source. However, we are a very small team, so we make sure the technologies or even the open source technologies ideally are cloud-based or provided as software as a service, are managed as much as possible so we can focus on the business value of the outcome and not spending a lot of energy and time in actually getting things running. And the last principle that we have put in place for ourselves is to say we do have to make sure that we continuously reassess the platform that we're building that is empowering the analytics department and make sure, okay, hey, is every part that I have still crucial and important enough to keep it, or can I remove something? Can we consolidate something? Can I replace something? Just to make sure we stay lean and fast as we move forward. All right, so this is a very simple graphic. It will be a little bit more elaborate, but what I wanted to show with this is a modern data platform or a data stack doesn't need to have 20 different layers and components. It can be actually very simple and very lean. We have 6 layers. One, the data generation, where all the data is actually generated, source systems or APIs that we consume. There is an infrastructure layer that actually is a horizontal over all platform components. There's an ingestion layer that makes sure, okay, hey, all the data that we pull in has to go through one central layer, storage and transformation. That is where the magic happens usually. So obviously you store your data in, let's say, a regular data warehouse or in a graph database, whatever you name it. And we currently use a cloud data warehouse for the use cases we have. The transformations, it's up to you. To be honest, we use DBT. I'll show you. It's where you combine your data in a way where you can extract meaningful insights and information. It's where you model your data to be harmonized across different data sources. Sure, like knowledge graphs are one thing. As I said, we use out-of-the-box solution from the industry, DBT, which is a data modeling tool, if you want so. And then there is a serving layer that enables your end users to consume the things, the data products, or any insights in the serving layer during or throughout dashboards or other APIs or reports or whatever. It's up to you, really. So that is the main setup, and this is just an example how it could be, right? How you can fill these things with certain tools depending on how you want to build it. As I said, what we've tried to do is we try to use a lot of managed services, a lot of services in the cloud that take away the overhead of running these systems, and where we can focus on building the data product itself. In the middle, in the dark blue, you'll see that's where the actual magic happens, where we say, okay, hey, here's where we combine our data in a way that then on the serving layer on the right, the data science team, the people that build forecasts, like data science models, or just like information retrieval through our dashboards, they can sit on top of the warehouse and provide a data model and build data products on top of that. This is just one way to do it. Obviously, there are different ways depending on what your use case is. What this approach we took is a best of breed solution. So there is not one solution that covers the entire end-to-end setup. We said, okay, hey, here we can go in and replace certain things where we think this is not suitable for, I don't know, more advanced cases or not. These are established tools in the industry, and what is also very important for us, and it's one of our principles where we say, okay, hey, it needs to be somewhat event-driven. All of these layers, all of these tools, they integrate very nicely and seamlessly together. So the time from ideating to actually bringing out data products, and also more advanced data products, is rather fast. All right, then I'll hand it over to Simone.
All right, thank you. As Jonathan has already mentioned, we're not doing any knowledge graphs yet. However, we're exploring for which use cases it might make sense to use LLMs, and I would like to introduce two of these use cases to you right now. So as you might know, we're collecting fan feedback in many situations. So if you go to the RB Leipzig shop, you're buying a jersey or anything like that, we ask you, were you happy with your experience? Also, if you come to a match day, you come to the stadium afterwards, you can participate in a survey where we're collecting both quantitative and qualitative KPIs. And as you can imagine, we're retrieving lots of feedback, and of course, our main goal is increasing the fan experience. And with all these qualitative answers, all these open responses, we have lots of feedback where we're exploring right now if it would make sense to use an LLM to summarize the most important points for us, to get a good overview on the main pain points, and then continue working on improving them. Second use case, what you can see here is a density map, and you see ticket sales in a certain zip code area. And we're overlaying this with opportunities for having marketing campaigns, doing advertisement. And one thing could be that you can have targeted advertisement. Just to give you an example, you know you have lots of fans living in a certain area, and you have a special event going on at RB Leipzig. For instance, you want to offer some backstage experience, meeting the players, special events, and you would like to make advertisement for these opportunities. Of course, you would spend money on the media campaigns in an area where you have your target group. So you want to reach the fans that are actually relevant for the event you're promoting. And this is something you could do here. And again, this is also showing some potential for LLMs, because once you know all the different marketing campaigns you want to do, you can try exploring if you can create them automatically and if this would make sense. Again, I'm saying we're currently exploring this. These are some use cases for us where it would make sense to dive deeper into it, but it's not in production yet. Thank you. We're now open for your questions.
Thank you.
Thank you. Are there any questions? No, then yeah, maybe. I have a question. When I saw your architecture, I think it was not entirely complete, but in young companies or in young endeavors, you often see there are a lot of external services that are used, whereas in bigger companies, they really struggle with having giving their infrastructure in the hands of other companies. How is the decision made in your group?
Yeah, that's a good question. Thank you. I mean, as we mentioned before, we just started up recently, and we do have certain guardrails in place where we say, okay, these are things we need to keep in mind when building a platform. One of that was the maintainability mandate, where we say, okay, hey, whatever we build, it needs to be in either very well documented or it is a publicly available solution that is documented as such. So as you were able to see most of our solutions, I'll just jump back. Our external solutions, there's no custom layer, no custom developed service yet that is critical enough. So most of the time it's, we say, let's keep it simple in this case, and people are able to continue operate or maintain these layers. Obviously, as you grow and you do build certain custom things, you might have to also be aware of the fact that if you do release it, that it's well documented, that you provide trainings, and it's not only with one person that can run that.
Yeah, thank you. Okay. Our next speaker is Achim Reitz from Neonto, and he will show us how to evaluate, or how they are evaluating, knowledge graph quality.
Yeah, thank you. Yeah, I'm Achim. I just finished Rostock University as a PhD student, even though the PhD is not yet finished, but I finished Rostock University. And since 2 months, we are working on a spin-off, bringing the PhD work into the business community, and basically working on how we can evaluate graphs, knowledge graphs, and the underlying ontology, and make them higher in quality, and reduce developments that go in the wrong direction. So first of all, let's clarify what is even knowledge graph quality. So there are various viewpoints we can look at when looking at ontology quality, for example, and just looking at the schema data now. So, for example, we could aim for accuracy. So are we actually mapping or modeling the right things? Adaptability. Can we take an ontology and put it just somewhere else? There's clarity. Can we give an ontology to somebody else and he does understand it? There's completeness. Are we actually covering the whole domain we shall cover? And organizational fitness is interesting. The icons look different on my computer. Organizational fitness. Do they fit our company or enterprise that we are working on in our industry? And I think going through these elements, we can agree they all make sense in some kind of way. So we look at that and think that is probably something we should aim for when building ontologies. But at the other hand, they kind of contradict each other. So looking at, for example, adaptability and completeness, so we can have a really completely covered domain and all its specifics, but probably we can transfer it to somewhere else. So it's not really that we can have all of them at once. And in the end, it's quite high level. So we know for things that we should or may want to achieve, but we don't know how to get there yet. So let's go to measuring, to the fun stuff. There are 4 large areas of ideas on how to evaluate graphs or knowledge graphs. And one key takeaway already I can say is I think only one is a really good idea, but let's go through all of them in a bit. So, first of all, there's a gold standard. We could think of a gold standard as having a perfect ontology and then evaluating how far off are we actually to this considered perfect gold standard. That works for retrieval tasks. We can evaluate, for example, for an LLM, see how good it actually is compared to our perfect modeled ontology. But if we want to build enterprise-wide schemas, that probably doesn't work, because if we would have a perfect ontology gold standard, we would just use that. So that is kind of out of the picture. Then we have corpus-based evaluations. So we have a corpus of text or copies of documents, and we want to see, are these concepts in our ontologies also in the corpus of text? Do we have an overlap or not? Again, good for retrieval tasks. I think not so good for building, maybe for taxonomies, but not for building enterprise-wide ontologies. Application-based, I think it's quite a good idea to see how our knowledge graph performs in an actual software, and see whether there are mismatches between our data and the connection of applications. Unfortunately, though, I think if we want to build a good and usable knowledge graph, our idea is to break down silos. And if we now focus just on one application, we probably can get to a point where we over-engineer that for this one application case and miss out the larger picture. So that is quite of a risk in application-based evaluation. That leaves us with structure-based evaluation, which basically means we take the inherent properties of the graph and look for properties that we want to have, we want to achieve, and for things that shouldn't be there. One really popular structure-based evaluation that I bet most at least have heard on already is the shape constraint language. SPARQLing allows us to specify how a graph shall look. So for example, that's probably a little bit small, but we can say that everything that is a person is evaluated with the person shape. So with this constraint that we are giving, every person shall have a name which is a string and only and exactly one name, only in exactly one age, which is an integer, and at last it can have 0 to 2 parents, which are persons as well. And with that SPARQLing constraint in place, we can now pretty easily go through actual data instances and find mismatches, find constraint violations. So, for example, here in the person 4, we are seeing that we are having an age defined, but it's actually not an integer, it is a string. So, and depending on our SPARQLing validation engine, that would give us an error. And here, pretty classic thing, we have person 2, two names attached, Alice and Alice. That is also definitely a heterogeneity in the data, which is SPARQLing really great for identifying these kind of mismatches. And yeah, I think SPARQLing, it's just at once. Yeah, SPARQLing is absolutely fantastic for doing instance-based validation and to really make sure that we are developing the schema so that the data that we are integrating is actually conforms to a standard. It closes the world that we have of the OVL and RDFS, and it's a practical way of modeling business rules in our data. However, we want to evaluate the whole quality. We also want to evaluate the schema, and obviously SPARQLing doesn't evaluate itself. So we can only have good SPARQLing validations and good instance validation if we have good SPARQLing rules in place. And what SPARQLing doesn't give us is a bird's eye perspective. So we quite can't see are we actually getting where we want to be in 1 or 2 years. It can show us a mismatch between data strategy and data execution. And in that case, I want to emphasize that SPARQLing is a validation engine, and these validations can give us evaluations on our data if the validations are good enough, the constraints are good enough formulated. But I'd argue for a good evaluation of the whole knowledge graph, including the schema, we need a little bit more. We actually need to connect data strategy and the data execution. Going back to the start, there are a lot of things we can aim for when developing ontologies and the underlying graph then. And we would need to ask ourselves, what do we even want? So, for example, when developing a top-level ontology, we should aim for a high adaptability, a high clarity, but we can forget about the completeness, because it's just a small bit that we want to see integrated. And then we can actually ask ourselves what kind of attributes are represented by the things that we want. So again, staying at the top-level ontology, there are KPIs that could measure, for example, is this top-level ontology reused in our domain? If not, that probably points to a problem. There are a lot of aspects we can measure in graphs. Depth, number of paths, number of nodes are one of them. The number of individuals indirectly restricted by shackle shapes, again, an idea for evaluating top-level ontologies, whether they are evaluated through the inference hierarchy. Do our shackle constraints have messages? Yeah, and all that can then point us to potential mismatches. So here, just a quick example. On the top, we are seeing the number of classes. And the middle line, these are object properties defined on classes. And if I would expect, or if I would see rising in classes that are being developed, I would actually expect that these classes also should contain object properties, right? So that already can be an indicator of that there might be something off. Yeah, to wrap things up, for evaluating a good knowledge graph or a knowledge graph evaluation strategy, I think we first need to understand what these artifacts are actually used for and built for. Then we can derive requirements like actual structural data requirements. How should the data look? And afterwards, there are a lot of things we can actually measure, a lot of things we can quantify for understanding whether data and schema goals are met or not. Yeah, that concludes my talk, and I'm happy for any discussions or questions. Thank you.
Thank you. Any questions? Ben?
I guess we're very interested in using Shackle in your primary use case around making sure the data is consistent and that. But we're also interested in using Shackle or exploring how we can use Shackle to test the quality of the ontologies we build, not in terms of what we can do with them, but are we, when we version, have we introduced any errors into it? Is this consistent? Has each class got a corresponding SCOS vocabulary associated with, et cetera, and those sorts of things. So those things are just treating it as data, right? As opposed to against some other metric, yeah? So we can use Shackle to do those sorts of things. What would you recommend for going beyond that, though?
I think what we are mostly interested in, but it's going in that direction, is so having rules in place for the data that the data shall comply to is one thing. But I think data strategy is a more holistic area of where do we are now, where do we want to be, and are we reaching these goals, and are we getting towards this goal? And I think having these rules in place, one potential place or one potential way of evaluation is how many rules do we actually have? Are we having more rules? Are we having more validation of these rules or more violations? Could be a great way of understanding whether data strategy is met or not. But I think that's already a really sophisticated way to use Shackle also for the ontology, definitely, yeah.
Thank you.
I'm going to have a remark also on the shackle stuff. Shackle is most of the time used to validate the data in the graph. There are people like Matteo Lisandrini, I think. They generate shackles statistically from the graph, so you learn about the structure, the implicit structure you have in your graph. So what do I have in my graph? I extract these structures, and if I study these structures, then I know what I've built. Because most of the time, graphs are built iteratively, merging data because it's so easy. We don't have a model, so we put the data in there. And analyzing the structure that are statistically significant in your graph, you might learn what you've built.
Yeah.
It might not be what you want, but you know this is what you did.
That's a great remark. I know that there's a really active community on this kind of automatic shackle generation, but it's great to let's drink a coffee later on. I want to hear more about that.
Also a question in this direction, because I'm quite interested in data quality. It's often neglected, but it's actually very important. To what extent do you define your rules in shackle, or do you define them manually, or do you, you can also have like very custom rules where you can enforce some statements, or where you can enforce some, I don't know, a certain amount of people in a football team, things like that. So what's your approach there?
Honestly, this disclaimer, I'm not an expert in shackle. We are the measurement guys. We're really interested in how shackle evolves. So I think like I might not be able to answer that. But the way I experience that when speaking with the industry is, that is kind of like we placed all the old RDFS world, or not RDFS, but basically the old world, and in the way of like completely from the top level to the domain level, working with shackle instead of, I don't know if that answers your question. But,
Thank you.
Thank you.
Yeah. So our last speaker is Vincent Vialard from Derivo. He will give us a presentation on their visualization tool.
So let's try to get this working first. Looks like something's happening. Yes. So it's a perfect closing talk after what we heard before. So we have a small company founded about 15 years ago in the artificial intelligence lab at the university in Ulm. And we have a background in automated reasoning and knowledge representation. We have been supporting companies with a knowledge graph project for the last 10 years and working on developing software around knowledge graphs. We had our own inference engine for all 2RL. So in the semantic world, but the data was stored in Neo4j, so we already had a kind of a bridge, early bridge there. And finally, at some point, we started working on our knowledge graph exploration software that used our inference engine as a storage. But in the meantime, we are a reseller for RDF Fox, so all our reasoning tasks are done with that, and we focus solely on the exploration. What do you want to explore a knowledge graph? You might want to investigate a case, and this is actually the UI of SemSpect was founded by an intelligence administration that was investigating cases. So you are at the instance level, you start from facts you know, and you try to connect the dots in the known. You might want to gain insight. You are at the meta level, at the model level, and you want to understand the structure of the graph. What do you have in your graph? What did you achieve? And exploring the graph might trigger new questions because you see connections that you might not expect, or you might miss connections that you would want. And finally, and this is our main usage at the moment, is check the outcome of data manipulation steps of your graph. If you use Essenza corporate memory to integrate data from different data sources, you have a result. It's a big graph. There's lots of data in here from your different data sources. What did you do? You want to know at the meta level, how did you connect the stuff? What is the main structure of your graph? But you want to go down to the instance level to verify that the generated data is correct, that your fields were converted the right way. And of course, you could write your shackle, but if you can write your shackle, you can write your specification. If you can write this specification in this way, maybe you don't even need a graph. You can outbake everything in the code. Nobody is gonna, I've not seen a project where everything is specified in shackle from the beginning. So what we've been doing the last weeks, we put shackle error reports in the graph with the data, so we can explore it at the same time. And we also have data in 2 different name graphs for 2 different versions, and we calculate the differences. So we know what are the new assertions, what are the new edges in the graph, and we can explore this. How do you want to do that? If you take a classical network rendering at scale, no chance. Poor expansion control, disorientation all the time due to node rearrangement. Every time you expand something, everything's wrong, and you don't have an overview, a structure overview. There is a kind of overview. It's good because it's data-driven. You see only the data. You are not writing a query that might give no result, and you don't know, is my query wrong, or is it expected to give no result? You have a detailed local network. So if you are interested in not many nodes, you might identify loops. You might have outlier identification, like the things you see in the middle, the big dark, or the things that are alone. You could spot them visually, and it's aesthetically pleasing. And that might be one of the reasons there are so many publications about this. What do? We want to avoid the airball, so it's not as sexy maybe as a colorful graph, but we propose a scalable exploration at the meta level. We group the nodes, we aggregate the relations, we still use a data-guided expansion because you don't want to go in a dead end. We don't want to build something that leads to no result. We want to have access to the details on demand and interactive filtering of our exploration. What we are building here is a path. It's a query path where we specify the classes, the relations, and filter on the attributes at every step. What you're actually building here, the last node of this path, it's the result of a query. We have our abstract syntax tree in our software, but we can convert this to Cypher for Neo4j or SPARQL for RDF data. So we are a no-code query building software. And the tables are back. And in the intelligence domain, they were delighted to see their tables back. Because when you have only the graph, people coming from the tables don't recognize their data. So I think it should be about the right time to do a demo. This is the DBLP data set. We have 67 million nodes. And I'm going to be bold. I'm just going to move these here. OK, I've got to connect to my phone, I suppose. Yeah. Here. It's a demo. It's a live demo. So actually, I could run this on my laptop, but I generated the indexes on the server. So I think I'm going to try this again. It's hot swappable, the backend, so it works. What do we have? We have this 70 million resources here. We see here that there seem to have ontology going on, lots of relations. What can we do? What can we say about this? Oh, they are connected to resources. lots of different relations. We have identifier, creator. It seems like we are different kinds of resources. Oh, they are listed here. So I'm going to do something. I'm going to deactivate this level here. And now when I expand this, I have the connected classes. So I ignore the resource because everything is a resource, and I go directly to my authors here. So now I'm exploring the relation between resources, some kind of resources, and authors. And I just explored here all these relations. We have person, we have group, ambiguous creators. Let's go to the group. Restrict to the group. Oh, that's a number I could display on my screen. So let's raise the threshold here and see the groups. Oh, lots of groups. What do we have here? 168 et al. Was that for a group? I know this group. It's the group with the most publications in there. So DBLP, you have a problem with your data here because et al. Is not a group. So this is just demonstrating how, starting at the top level, starting to dig down here, we find like problems in the data. I'm going to tag this one. And I want to explore from this one resource what are the documents that were created here. And okay, articles, informal proceedings. Let's focus on the articles. I restrict here to my articles. Now I have the articles of this et al. And now let's have a look at what we have. And let's have a look at our table. And we have different number of columns here. And if I select one of those, it's the red one here, we see we have a dossier. And what we reverse engineering the data in the graph and to see what are the properties, at what level of the class hierarchy are these properties used. Never trust the domain and range of your knowledge graph. You're gonna break your nose. So we reconstruct this and we inform you about where we found these fields to be relevant. And let's see, do we have anything about RDF in there? I did not try that, so I'm not sure. It's only 124. It would be quite a chance to have something about RDF et al. No RDF. Okay, never mind. Let's start with something smaller. We're going to start with these bietet entries. I'm going to make that. Make this big. I'm going to tag all the resources here. What do we have? Okay. Different resources. They are all documents with a bietet type. Yeah, seems like we are fetching all the resources in order to build these exploration menus. We also have to tap into the surroundings of the thing. Here we have documents. Okay, what do we have? Documents. In proceedings, article, informal, book, editor, in collection, withdrawn. Oh, interesting. Data. We have a PhD thesis here. What are PhD theses about? So I'm going to PhD thesis? Okay. What do you think PhD theses are? Oh, they are a book, except for one that is withdrawn. What I'm going to do, I loaded this RDF data set in memory in my SemSpec. I can do nothing. I cannot modify the data. I can modify the data. I have my class here, and I say, okay, this is a PhD. And I know I'm modifying the graph. It's not relevant for the RDF case. It's more for when you have your data in Neo4j because we write the labels back on the graph. So now I defined my PhD class. We have to reload the graph because we have a new class in our graph here. Okay? And now I can restrict this to books, and these books, I can exclude the PhDs. So these are the books that are not PhDs. Who do you think? Okay, 20,000 creators. Show table. We have an interesting column here. It's the number of predecessors. It's the numbers we had in the small things before. And who is no surprise to find Knut as the author of the most of the books that are referenced in there. So we can validate that things seem correct, and we found things that did not make sense. What's my time doing?
You have 1 minute for the presentation and 5 minutes for questions.
Okay, so I'm going to show a last thing that I discovered. Here we have our personal identifier, and they are connected to documents. So this is something I could have expected to find on the high level. This is DBLP, the guys know what they're doing. It's not someone throwing his data together. So this is the kind of problem you find everywhere. Having inconsistency in your data. And if we have a look at the identifiers of these documents, we have 20 identifiers. We have resource identifiers, conference. Okay, these are resource identifiers, and we have personal identifier. And if I highlight tag object with this class, we have something valahu dash valahu dash valahu dash. There seems to be a pattern. So this might be one of the sources for the problems, the mismatch we have in the data here. So I'm going to wrap up this. Key factors for visuality at scale. You want an overview first. You want to be able to get to your details on demand. You want a stability, predictability of the visualization. I am never surprised when I expect. I know how it's going to behave. And I want a data-driven exploration options. I want to know what are the paths that I can build in my graph. Semspect, we have an RDF server with dedicated in-memory indices. Is the one I showed here. The official release is available since 2 weeks. It's free completely till July, and then maybe we'll advise. There will be a free version with some limitation. Neo4j, we have a graph app for Neo4j desktop that is free for your local usage. We have a plugin for Neo4j server. And if Neo4j is too slow, Neo4j is the best store for this kind of queries, for this kind of exploration queries. But if it's too slow for you and you want to use RDF server, we have an open source Neo to RDF a library that was developed especially for our needs, but we said we are not the only ones wanting to get our data out of Neo4j. And license are available free of charge for academic and open data projects. So you can shoot for the questions.
So, are there any questions?
You left out zoom and filter in your Schneiderman mantra. Did you do that on purpose? Overview first, details on demand?
Okay. These are the tables filter you might find in here. Let's start with this. I will have the persons here. I have all the documents created by these persons. So I have mainly most of the content of my database here. And then let's look for local person here. Creator. No. What did I do? Certain hour? Maybe it's not the. I've got to go to the full creator name here. I thought it was in there. Okay. Here, restricts to selection. Path. So you can restrict any node at any time, any node on your path, and focus on your thing. And here you have your SPARQL query, and you also have your SPARQL query of all the details here. So you can give your data guy, you want to have this in your dashboard, you give a query.
No, I got that the user interface does zoom and filter. I was more wondering that you, the presentation title and also the summary said overview first, details on demand.
Yeah.
And in this Schneiderman mantra, which you kind of quote, it usually says zoom overview first, zoom and filter, details on demand. So I was a bit wondering if you on purpose left out the zoom and filter part.
No. No, I'm not aware of this citation. I think we came up with a text
okay.
like this, so it was not a citation, not voluntarily.
Yeah, but it is one.
yeah, but we have the zoom because when I focused on the PhD thesis and see how they were connected, I was focusing on one individual.
Yeah. And thank you for bringing back the tables. I think that I like a lot.
Yeah, you're welcome.
Okay. Any more questions? If not, then we can go to the coffee break. There's now half an hour coffee break, and after that there's session number 3 on ontology engineering.
Thank you.
Thanks, Vincent. And see you in the break.
welcome to this third section of today. And we're going to talk about semantic technologies and ontology engineering. So we're going to have some work spanning from delivering data to ontology engineering and also triple stores or new ways to query triple stores. So it will be a very interesting section. I hope you all enjoy. And our first speaker, it's well known or better known for, is the head or the leader behind DBpedia, which was one of the first large-scale knowledge graph and also multilingual. And I also think that they were a little bit too crazy back then. It's been maybe 20 years or something
16.
Like this. Yeah, 16 years. And since I know him, he's behind DBpedia and leading the project. And he also has some work, relevant work on data quality and also knowledge extraction. So, ladies and gentlemen, without any further delays, please welcome Sebastian Hellmann.
Thank you. So my name is Sebastian Hellmann. Today I'm going to present joint work which derives from the energy system analysis sector. So it's not technology focused, but more domain focused. And it is about FAIR data and energy systems analysis. And these are results of a LogGeos project, which has ended last year. The slides are available at tinyurl.com, LSWT -2024 -databus. Okay, so what is the databus? The databus is the data catalog platform. And metadata matters, yeah? So often data catalogs and data metadata are neglected because it takes extra effort to maintain them. Why do you actually need them? Yeah? And I would like to raise a little bit the awareness here. Right now, you might not wonder why your data projects are slow and of mediocre quality, because you probably never worked with good metadata and a good catalog. Yeah? Because then they would go a lot faster and you would be used to the speed. So the point here is that data catalogs, they offer a high potential for innovation. And that means you can realize data projects faster, cheaper, and better. Yeah, so that is the potential they offer. So I would like to tell you about the DBpedia databus. It's a lightweight, scalable, adaptable, powerful data catalog platform. It is open source. Available on GitHub, and it addresses exactly the lack of open source data catalog software. At the moment, the DBpedia databus is deployed in many different areas, so supply chain management, engineering and industry 4.0, knowledge graphs and AI, data governance, especially in large companies. And today I'm going to talk about the deployment of research data management in this energy system analysis sector. So the predominant project here is in the sector is this open energy family, which has a lot of different parts to offer. And the open energy family is an initiative for open and fair data in the domain of energy system research. So what is energy system research? They develop models to evaluate and compare future energy scenarios. Yeah, that is the core of their research. And the scenarios are like, for example, electricity demand and offer at the energy exchange agency. That's the Leipziger Strombörse. Yeah? And here, so the goal here is development of a fair infrastructure within the open energy family. So what are the three parts of this? So there's an open energy ontology, there's an open energy metadata standard, and there is the energy databus, so the deployment of the databus software for this area. So here I'm going to present some of the challenges that we faced during the LogGeos project, and now we believe that we are very much farther in solving them. Yeah. So what was the state? Most of the research data sets in this area are already online. Yeah, but the fact is online availability, that means published data sets, online availability is not findability. Yeah, because findability is search over these online available data sets. And many pain points exist in this area for energy system researchers. So data collection is a labor-intensive task. Data cleaning, aggregation, yeah, is repeated by many researchers over and over with different results. And then data quality is often unknown. So you have basically it's very difficult to find and access data. You can imagine a library with books, yeah, but the library doesn't have a catalog, and the books do not have numbers, systematic numbers on the shelves. Yeah, so you just have a lot of things, but you do not know where to find them. So the solution to this is semantic metadata, building a semantic metadata catalog. So a metadata catalog harvests the rich metadata from the available data sources, and the data sources are displayed here at the bottom. So these are the systems that researchers normally publish their data. So some publish on Zenodo, some on GitHub, some on CCAN, some have their own FTP or file servers, and then there are, of course, data project landing pages available via HTTP and HTML. Yeah? And all this metadata can be harvested and put into a combined metadata knowledge graph, which provides unified access, and the catalog can be used to discover data, and all the metadata contain URIs to the actual data, so a download link. Yeah, so that is what you actually find in this metadata catalog, the download link of the data in various different systems. The other solution which we provide is effective search over data. So again, findability is not online availability. And normally effective search needs domain customization. I'm not going into it too much, but it's called the no free lunch in search and optimization, NFL theorems by Wolpert and McGrady. So what we built here is called the metadata overlay search system. Johannes was one of the major developers of the concept as well. So MOS. And what it does is, first, it extends the database core graph with custom metadata subgraphs. So you have these core metadata, and you can extend it very easily. And the second feature of MOS is that it indexes these subgraphs for searching. So how can you imagine this? So this is a schematic of the core metadata of the database catalog. It extends and also improves DCAT significantly. So the core is that you have users who publishes group and artifacts. So they are aligned to different versions of the data set. And then you have basic metadata like title, abstract description, license, which has to be URI. And then distribution, which gives you the download link, the format, the compression. Yeah? So the extension that MOS now offers, the metadata subgraph extensions, comes in different layers. Yeah? So everybody basically can create their own standardized layer to attach to this core metadata graph. So what we see here is one example of ontology annotation. So the files in this energy system research are mostly CSV or tabular data. And then you can just, for example, attach an ontology URI to the file. You say the topic of this file is wind energy, yeah, or some concept from the open energy ontology. So these are a simple annotation layer, for example. But then the open energy family also produced this OA metadata standard, which is like a whole graph of extra information about this CSV file. So you have the topic, the units are described exactly, whether it's square meters, square centimeters, or some energy value. Time series can be described, how it's averaged. There's table header info, and then also this is also ontologically described with this subgraph. The second part then, this gets indexed into the search system. So all these graph layers get indexed, and you can search the data with the metadata overlay search system MOS. So how does it work? You start typing your search term normally, then MOS finds the terms from one or different ontologies, depending on how you indexed it. And these terms can be selected for search, and you would retrieve the download links based on this ontological concept. So you would find exactly the CSV files matching to the exact ontological concept you are looking for. Yeah? And this can be configured and fine-tuned in the background because the search needs optimization for the domains. Yeah? So as a summary and takeaway, I would like to talk about the data bus. So the data bus is comparable to an open source Hugging Face or a Google dataset search. Yeah? So it is more a tool that adds a semantic layer over existing data sets which are distributed on the web or on Zenodo or GitHub. Yeah, so you can compare it to Google Dataset Search. But the database per se has a very different purpose and mission to online data publishing portals like Zenodo, Invenio, CCAN, the Leibniz Data Manager, also the open data portal Saxon, which are more centralized solutions to publish data in a central place. Yeah? It is already gaining adoption, especially in this energy system sector, because the databases are interoperable and they form a network. Yeah? And you can then query also over different databases. Yeah? It's like an interoperable data catalogs. And it's open source and free. And in case you need it, we offer support and manage hosting for it. Now I would like to talk about this transformation that is happening in the energy systems research sector. Yeah? So they have the right mentality. Yeah? So it was a collaborative project. I'm not an energy system researcher, but we were in the same project. Their understanding is that fair and open data is a necessity for their research. So the more data they can find and the more adequate data they can find, the better the scenarios will be they can calculate. Yeah? So for them, this findability is a central point for their research. And for them, it's also clear that this is a productivity factor. Yeah? Because so fair is like the reuse is very important. Yeah? Then the transparency. And then also the licenses are also important because otherwise if there's no license clarity, you are not sure whether you can use the data set. Yeah? And this is also, it hinders productivity. So they have this right, in my opinion, the right mentality. The great achievement of this open energy family is that they succeeded in producing useful standards. So they created an open energy ontology. They created this open energy metadata, which standardizes metadata in the area, and they use a database as a data catalog, as a tool to fulfill this and put this into operation. Yeah? So what we do there, so this supports researchers in finding relevant data, trace provenance, and also automate workflows for models and scenarios. I have one more thing. We have the opportunity to win the Sächsischer Digitalpreis. Yeah, so there's the voting at the moment. And please look at the video and give us your vote so we get the first place. Yeah, so we have been nominated there, which is quite good as the Open Energy Database. Okay, thank you.
Thank you very much, Sebastian. Very interesting talk. Do we have any questions from the audience? Professor Nogonga, at the microphone, yes.
All right. Hey, thanks. Quick cue. So you showed the search window, how do you deal with search semantics? So if you have things that basically are the same but have different names, or the other way around, how do you disambiguate that?
Well, so overall they have, the community created the open energy ontology to disambiguate terms and tackle the terms. Yeah, so this is like a consensus project, and many people are involved actually. So on this part, the semantics are clear. Yeah, at the moment, I was thinking, okay, you might be able to automate this now, especially in the times of LLMs, but they still annotate the things manually. Yeah, but the MOS is more like a metadata wiki. Yeah, so the distinguish here is that the core metadata for the data bus is given by the publisher, like license, for example, has to be given by the publisher. And then the community can maintain the metadata. So in this way, they can also change and agree on annotations and put the CSVs add them, assign the right semantics, yeah, in a community process.
Thanks. Thank you very much. Any further? Nathanael, please.
So I started the applause when you didn't have your contact slide on. It was for that you're nominated already.
Okay.
So,
yeah,
but it should not interrupt your talk. Sorry for that. And my question is, I'm working in library now, and in the libraries, OAI PMH, OAI PMH is a common interface for harvesting metadata. And the structure of the data buses seems to be somehow inspired by the way how such metadata repositories in the libraries are structured. Is there any idea to also make it compatible to such library interfaces, or not?
No, so I think you can see it here on the top right. Yeah. So on the top right with the unified access. Yeah. So the core model is optimized for querying with SPARQL. There are other interfaces like linked data or API or like the human readable search, yeah. But the core is SPARQL because it fits very well on the model, yeah. And this is the way you would subscribe to data, yeah. And there is an important thing here. That's why I said it improves on DCAT. Okay, DCAT 2, DCAT 3 now introduced this as well, which came out in January this year. But we support abstract data sets. Yeah? For example, DBpedia is basically the same data set since 15 years, but it's always new versions. Yeah? So you have this abstract identity of data set. So while DCAT 3 has this as well, I would also not agree how they modeled it. Yeah? So that's why we have this data bus ontology which extends it. But in principle, it's a polling protocol like OAI PMH, but it's open source, so you could also add a push. Yeah. So, for example, for all the search interfaces, also for MOS, we implemented a push. So whenever the metadata changes, the search gets updated. Yeah. And it's easy to imagine that this is like done via Kafka or WebSockets or some other technology, yeah, or RSS also, yeah. Like it's very simple to implement, actually.
Okay. Yeah, thank you for also pointing out the other integration points.
Thank you very much, Nathanael. Any other further question? If not, I will introduce. Thank you very much, Sebastian, for your talk. Really interesting.
Sorry, I
doesn't need to
right
mention
away because of I have to pick up my daughter. Yeah.
Doesn't need to mention that you can always talk with the guests or the speakers later, also in the coffee break. So if you have any other question, I'll write them in mail or something like this. So our next speaker. So today we have very special speakers here. He's well known in the community for his work in link discovery, question answering, entity linking, and today he's here to introduce or to present us his new endeavor, which is a new representation or query. He's going to talk more about it. So please welcome Axel, Professor Nogonga.
So I feel a bit like a rock star. Don't expect too much after that introduction. Thank you very much. My name is Axel. I'm a professor at Paderborn University, and I'm going to talk about Tentris. So the talk is going to really be in 3 parts. I'll give you the sales pitch. That's going to be the part where you go like, yeah, whatever. Then I'll talk about the technical stuff, where some people might be slightly more excited, and then I'll take you into data and numbers so that you actually see that the things that I talk about actually do work. So the motivation behind our work is really that graph technologies are really being used in an increasing number of applications, and basically Gardner suggests that graph technologies will be used in roughly 80% of the computes, especially analytical computes, by 2025. That brings about quite a few requirements when it comes to the storage and the utilization of knowledge graphs, especially with respect to the technologies behind really the use of knowledge graphs. And there are 2 main categories of technologies we're interested in. On the one hand, we want to be able to store large amounts of data. So basically, we need better graph databases or triple stores. On the other hand, we actually want to be able to learn on that data. So we need better machine learning solutions. And what I want to talk about is really a solution which combines both. And the reason why it's so important in modern data infrastructures is simply that, according to studies, roughly 90% of companies really face challenges when it comes to really managing data at scale. And when we think about it, and we think about the fact that AI could be used for these intents and purposes, especially in Europe, we have the problem that it's not only storing large amounts of data. As soon as we start running analytics, we are basically bound to certain laws. For example, most important is currently the GDPR, which basically says that we have to explain really the results of AI algorithms used on data, especially when the data pertains to humans. But we also now have the AI Act, which also has pretty strict statements therein as to when we can use AI, how we can use AI, and the types of responsibilities we have when we use AI. That basically means that modern solutions, which are AI-driven, must abide by, especially explainability, but they also must abide by scale to be useful for modern applications. So what I want to talk about is a solution that is, number 1, fast, scalable, and easy to administrate. Number 2, that is resource efficient. And number 3, which is explainable. And that's really what Tentris is all about. So I did not bring my super technical slides, but I will basically give you an overview of how you could use Tentris and then delve into some of the points. For the sake of time, not all the details, but after the session, I'll be more than happy to give you, if you're interested, even more technical details. So roughly, that is Tentris. Does the laser pointer work? Can you see this? I hope you can. Okay, so what is Tentris, or should I use the mouse? Is this better? Nothing means surely. So what is Tentris? Tentris is really a graph database. And standard graph databases are derived from relational databases, which rely on classically B+ trees. The problem is when you use a B+ tree, which was designed for linear data on graph data, you need to change what are called the collation orders. So you need several copies of the data, actually 15 copies to be precise, to actually be able to query the data efficiently. It turns out that one can do better than that. So the first innovation really of Tentris is the so-called hypertry. The hypertry is a universal monolithic index for graph data, and the hypertry really is nothing else than a representation of knowledge graph in the form of tensors. For those who are familiar with tensors, that would mean something to you. If you're not familiar with tensors, don't worry about it. Those are basically just big matrices that are 3-dimensional. The main advantage, though, of representing data that way is that we can provably save 33% of the storage index that way. Not only that, if you represent data in the form of a hypertry, you suddenly have what is called a worst case optimal join data structure. Worst case optimal join really simply means that you're guaranteed to be in the right complexity class when you're running your queries. What that really means with respect to time savings, I'll show you in a second. And Tentrace, or the hypertry, the data structure in Tentrace, is really the first data structure which is, number one, updatable, which means you can stream in data into the triple store. You can remove data from the triple store without having to update your data structure. That's one. And number two, which is at the same time worst case optimal with respect to joins, which means guarantees you that it will run efficiently as possible with respect to the complexity class. Now, as I said, you will see results in a second. That's the suspense part. The interesting part is, though, because we now have efficient querying, we can actually realize the vision of having explainable machine learning on knowledge graphs. The foundational idea here is we go away from using black box algorithms, so classical deep neural networks, for those who are familiar with those, and instead we regard the problem as a so-called class expression learning problem, which is actually pretty straightforward. If I were to give you examples of cities and tell you Leipzig and Chemnitz as positive examples, and Paderborn and Munich as negative examples, thank you very much. You would basically, and I want to tell you what characterizes or separates the positive examples from the negative examples, you would probably say, oh, those are cities in Saxony. The other two are not. Well, that's exactly what our algorithms do. So we actually look at the knowledge graph as a source of knowledge and are able to construct expressions which really, based on the knowledge graph, are in natural language and describe positive examples without describing the negative examples. If you want technicalities, we can talk about that outside. It's basically a mix of reinforcement learning and embeddings. I didn't want to bore you with that. What I do want to bore you with are results. So if you look at the runtimes, we really benchmarked our framework against the state of the art on a bunch of different data sets. Data sets that are very small, like the Semantic Web dog food data sets, which is roughly 300,000 triples, up to Wikidata, which is 5.5 billion triples. And we really asked the question, how well does the hypertry perform? And as you can see, if you look at queries per second, which are really here, I don't know whether you can see my mouse, can you? No. Oh, yes? Anyway, here over there, you can really see that Tentrace outperforms the state of the art, and that by orders of magnitude. Note that the y-axis here is in log scale. Especially on small data sets, we already have quite the improvement, but if you look at large data sets, you'll find that even on 5.5 billion triples, we do not only perform faster than the state of the art, most importantly, if you look at this line down here, that basically shows you the number of queries which either were incorrectly answered or actually were simply did not terminate in the computation. And Tentrace is the only system which on the Wikidata benchmark is able to terminate all queries within 3 minutes. So that's basically for the Tentrace part. Skills, results are correct, provably correct. Most importantly, if you also look at the benchmark of the explainable machine learning, you'll find that our algorithms basically are up to 4 orders of magnitude faster than what has been available so far. So there has been some work on class expression learning in the past, but what has been done here was mostly using so-called refinement operators, and they are renowned for being very, very slow. By combining triple stores with reinforcement learning, we're able to push down really the runtimes while maintaining the performance, ergo the F measure achieved by the algorithms. So if you want to summarize what Tentrace is really a storage solution which includes explainable machine learning, leads to 10 times lower operational costs, 100 times the reduction of CO2 emission while having a performance which is roughly of the order of magnitude 10 to the 3 compared to what is available out there. I hope I was able to make you interested. I did not delve into all the technical details, but I'll be more than happy to talk about them if you are interested. Thank you for listening.
Thank you very much, Professor Nagumi. We have quite some time for questions, if there are any.
Talk to the 10 minutes that I want.
So perhaps I can do some questions then.
Sure.
Which types of query Tetris can handle? Can handle all types of queries, or is there any limitation? For instance, can I run search like you do in SPARQL, or what are the limitations? Let's put it like this.
Currently we are completing the implementation of SPARQL 1.1. Tetris is almost SPARQL 1.0 complete. There are a few minor features that still need to be implemented, which have to do with the fact that the interpretation, for example, of XML data types is actually quite odd if you read through the RDF specification. So those are minor details that are being fixed, but we can basically run most of SPARQL, if not all of SPARQL, apart from data types and the like. We also support GraphQL. It turns out that really the hypertry as a data structure is really query language independent, and all the query languages really are built on procedural subunits, and each of these procedural subunits can be mapped to a tensor operation, which basically means that we can support any language.
Thank you very much. So if nobody has any question, I will keep doing questions here. Keep going. Maybe there.
Just the question on how do you want to proceed, or how can we, for example, try it out to install it locally or online?
Sure. So there will be a Tetris.io webpage available online by, which month are we? We're in April, aren't we? Latest by June. But you can also send me an email and be part of the closed beta. We are running closed betas to make sure that the performance of the platform really abides by the characteristics that companies want to have. We've done a first round already. I'll be more than happy to include anybody interested into the second round. So just write me an email.
One follow-up question to his question: if someone wants to contribute, is there an open source version or something like this?
There is an open source version. So we run 2 open source projects. One is the Tetris project itself under GitHub Dice Group Tetris, but there is also RDF for CPP. So one thing that was important to us, the whole framework is written in C++ for the sake of efficiency, and there was no clean C++ library for RDF. So we built it, it's available online. You can contribute or use it. We're more than happy to support.
Great. So maybe one more question. So we'll do this question then. When the paper came out, I looked into the paper, and then I saw that you basically, the whole metrics thing, then you are using basically GPUs, which is really smart. I saw a talk from the NVIDIA CEO is explaining, and it was really clever that actually what NVIDIA brought to the market is a new way of computation. And I think it was clever that you used that. But I've seen also movement in database to also utilize this type of hardware, which is also clever to do. And there are some databases that I think are already supporting GPU, so basically you can run this multiple processing on parallel and utilizing tensors, basically. So my question goes, have you looked into this database? Because it seems to me when I looked to the model, I haven't tried or anything like this, but it seems to me that it's visible or it's technically possible to map that to a database if the database has this support. So have you been looking to that, or?
That's a very fair question, and the answer is going to be fairly technical. So if you look at the complexity of answering queries on a tensor of dimension D, it turns out that in the hypertry, the complexity goes with D factorial, whilst basically in classical data structures, it goes by 2 to the D, which basically means that you only have an advantage up to D equals 4 roughly, if you consider the factor in front of it. Relational databases typically have a D that is larger, which means that the hypertry would have to be modified to actually fit relational databases. However, knowledge graphs do not have that problem because they are K-regular tensors, right? So 3 regular tensors to be precise, which basically means that there you're guaranteed to have improvements. That's why the hypertribe was actually designed for knowledge graphs. It's a very, very good question. The answer basically lies in the complexity categories.
Great, great. So let's everybody, thanks Axel.
Thank you very much.
Professor Nagonga. If you're a little bit shy, you can still catch up in the coffee break. So our next speaker, it's my colleague, Dr. Arndt, which I had the pleasure to work with. And he's also known by his previous work on distributed social network and also RDF versioning with Quit, which I also participate in this work, had the pleasure to participate in this work. And today he's going to talk a little bit or introduce to us what he's been doing for the last months, couple of months. And so please welcome, ladies and gentlemen, Dr. Arndt, which will speak about the web archive. Thank you very much.
Thank you, Mr. Marx, for this very nice introduction. Yeah, so for a month and a half, I'm working at the German National Library now, and I was employed there for building up the future web archive. So I will introduce you into what this is, the future web archive, or what is web archiving in general, and what I plan to do, basically. So I didn't complete it yet, but here you see my sketch of the archiving lifecycle. Many of you know the LOD2 or the linked open data lifecycle already, so it was clearly inspired by that one. In general, web archiving involves that we do some selection, some intellectual selection or automatic selection of what we actually want to collect. Then we actually collect it, which is done in a web archive by crawling or fetching the web pages or scraping. The 3 terms are more or less synonym in this context. Then we need to verify the quality in some way, or throughout the process we need to verify the quality that we actually got what we wanted. We need to index it, since we're working in a library, or it's an archive library. We need to put it into the catalog, and then we actually need to store the archived web pages. We need to have a way to find them, to search for them. We do it with the index, with the catalog, and then we also want to provision them to the users. So the background of why we're doing this is that in the law regarding the German National Library, which was passed or which was changed in 2006, the German National Library received the task of collecting, cataloging, indexing, and archiving non-physical media works, which are online publications in specific. So before we had the task to collect media works, now we also have the task to collect non-physical media works, unkörperliche Medienwerke in German. And examples for these online publications are electronic magazines, e-papers, so newspapers in their electronic version, e-books, university dissertations, which are also often published online, any kind of digitized content, music files, audiobooks, so music files and audiobooks. We also have the Deutsches Musikarchiv in our house, so all the bands around, you can deliver it to the music archive, and also websites and databases. First of all, I focus on the websites, but also I want to keep the databases in mind. So now I will show you, besides the abstract lifecycle that we have seen at the beginning, I will now show you my general workflow. So we start with the usage and research questions and the requirements in general. So we try to see who are our stakeholders and who are our users. Users are an important part of the stakeholders who formulate requirements, and those are the people who actually, for what this archive is actually built up, so that people can use it and research on the web archive. But we also have our collection mandate from the law, and who can tell that he or she is working on a job that is made by law. So we have this collection mandate that we need to select it, but we don't just want to select it just to have it in our dark repository, but we want to make it available for the use. So for to fulfill the collection mandate, we need to collect it, we need to select it, we need to crawl. The problems that we have when we crawl the websites is, the ways in which we can crawl websites are basically three major kinds of crawls that we can do, which are in the end all selective web crawling. Since we don't just crawl the whole web, we have the possibility to do a domain crawl. Many countries do that, like Luxembourg and Austria, but you can imagine that the German domain crawl, if we would crawl all web pages in the DE domain, it is huge. It's one of the largest top-level domains which are country-related. And so we tried it once. We didn't collect full DE. Maybe if we scale up our capacity, we will be able to try another DE crawl at some point. But so far, that's quite huge endeavor for DE. So we do event crawls, which is that we collect all the websites that are related to, for instance, elections, special sport events, pandemics, whenever they happen. And then we crawl pages that somehow represent the aspects that are related to that, so that people in the future are able to see what was important back then. Like all of these corona statistic web pages, which might not be available anymore. Even when we collect podcasts, which is also a topic, an open topic, at some point, to some extent, that we also collect like the corona podcast and all of these web pages. And then we have special crawls on request to preserve individual sites that people say, oh, I put all my life work into this web page, eventually it will go down, please preserve it for us. So in the end, we have a list of seed URLs from which we're starting to crawl these web pages. The problem the challenges that we have is that we often have highly dynamic content. For instance, the Data Week web page, it's a static website. We could just download it, take all of the images into it, and then we could preserve it. But we also have video streams in it, so we would need to download these video streams as well. In other sites, like in social media web pages, we have a lot of dynamic content that is loaded on purpose. We have some content that is specifically targeted to some local properties or to the cookies that you're using. And then, we have content that is behind paywalls, advertising, cookie consent, things that we have to somehow click away or somehow find the essential part that we actually want to archive, where things like the cookie consent is in our way and might sometimes also cover the whole content. Then we also have databases that we find online, which often have some nice exploration interface, but which might not provide a dump or some API or some other way to download it. So we have some exploration interface where we can enter some search terms and then have reciting websites. And I think you understand that that would be a very complicated endeavor to download a database based on the web representation. And then we have digital editions that also have their specific properties or ways how they are created. And in general, when we collect things, we want to put them in our catalog. So we have to do metadata harvesting. We have to find out the metadata that is connected to the websites. I mean, there's clearly the title tag, but there's a lot of more metadata. And there's also some metadata which is encoded in the imprints, in the impressum of the web pages, which is not formalized so that we can just get it like we would with RDFA, for instance. And so we have to find proper ways for that as well. So once we have collected the web pages, we put them in VARC files, which is the archive for web pages, the archive format. Then we import them into our repository, which is our storage infrastructure on which the day-to-day life in a library works. And from that, we also want to put it into the digital long-term archive, where this data is preserved for decades, hopefully longer, which is also, quite a challenge. And then we also put it into our catalog with some rudimentary information about the existing of this media work in our repository, but we also have to do the indexing, Erschließung. So we have some automatic process for the indexing, but it is also for many books, it's a manual process. I think for web pages, clearly we have to do it in some automatic way, and we can do it based on the content of the web pages. But I think also metadata that is available in some cases should be used or should be able that we can use it when it is available. Then we have it in our catalog, and from the catalog, we can start to use it. We can do research on the catalog and find out which websites are there, which media works are there, and do catalog research through the portal of the German National Library. And then we actually want to use it, so we have some provisioning process in general, and I will also rebuild this provisioning process here so that we have a technical index on the web archives, on the VARC files, which web page and which version is in which VARC file available, and where can we find which URL in the end, so that we can play back the web pages. But we also need some database access to these web pages so that we can provide people access with some Jupyter notebooks, for instance, or in some other way to research on the content of the web pages. And in the future, also web technology evolves, and at some point we also have to implement some emulation to emulate older web browser behavior. And all of this has to happen while we ensure the copyright, and that basically boils down to, so we replay the web pages to our users. We want to allow data-driven access, and we have to ensure the copyright, which basically boils down to exclusive access in the reading rooms of the German National Library. And via our catalog and web archive portal, you can actually access or find the individual objects, but often you can only see the replay in the reading room unless the rights holders granted rights to make the archived websites freely accessible worldwide. Since when a web page is published on the internet, the person who has the right to publish it publishes it there. But often a statement is missing if we also get the right to republish this content, and if we would make it available through the German National Library webpage or interface, then we would need to have the right to republish this content. Some readers give us, or some publishers give us this right. Sometimes publishers don't even have the full right or the full copyright of what they put online. For instance, that they license pictures. That is a big problem here, that they license pictures only for a limited amount of time, for instance 6 years or so on, and they might not have the eternal rights. That's the workflow. In partnerships, we collaborate on the international level with the IIPC, the International Internet Preservation Consortium. We are a member in this consortium, and also the Internet Archive in San Francisco is a member of this organization. And with them, we also have a special access to snapshots of websites in the DE domain in the Internet Archive. They have a different legal situation than here in Europe. And on the national level, we work together with divisions or we divide our labor with regional legal deposit libraries, because we have the German National Library, but also in each individual state in Germany we have deposit libraries. And in the public dialogue and workshops with other cultural institutions and relevant experts. The questions that I have to you is that you all are potential users of the Web Archive, and you might be interested in using the Web Archive. So in general, the Web Archive should provide a service to readers, which are interested people in general, scientists, in whatever domain, you name it. Domain of digital humanities, linguists, political science, photographic research, arts, data science, computational, social science. Those are the communities with which we so far mostly work together, but also in general, computer scientists, whatever domain you're coming from might be interested in the Web Archive. So I have the question, what would be possible research questions that you would like to answer based on the Web Archive, if you would imagine to have a nice Web Archive? And what metadata and what data would you deem relevant to, to be collected in the catalog regarding these archived web pages? So reach out to me, and I'm open for questions.
Thank you very much. Exactly on time. Thank you. So, you can also use the microphone to answer the questions. Don't need necessarily to do the question, right?
I think there's a...
Yes, from the chat, a question from the chat here, or several from Simon. The first one, how do you plan to deal with social media content as media?
Okay, so social media content actually is part of the endeavor of web archiving, so social media archiving, but social media archiving is somehow a specific subfield. We also had a conference on the specific needs of social media archiving, and there is some legal situation that the big platform companies need to give access for research in some ways, or they provide this access in some ways, but this is somehow a separate field, so I will not focus on the social media collection at the first place. I want to, first of all, collect the general web that is accessible besides social media, but there are also people working on social media archiving.
And he also asks, what kind of data can you collect from a legal or ethical perspective, and what role does provision of this data to users play?
Yeah, so our legal basis tells us that we just collect all of the media works that are published in Germany, relevant for Germany by German authors outside of Germany or in German language. In general, we have the right to do this, to collect it, but as we don't have the copyright, we cannot just replay it to everyone in the public web, but in our reading room, we are able to do that, yeah. And the ethical dimension, yeah, I think in general, yeah, we have to, I think, decide this on individual basis, as we are currently doing a very selective web crawling.
Any further question? Maybe I do then the last one. Very quick, how are you dealing with this metadata extraction on the web page? I can imagine it's really challenging because you have, I mean, different tools that generate different structure itself. So, or you are still working on that, or?
Yeah, I'm still working on that, or I didn't even start to work on that. But my idea to deal with it is take like the rudimentary data as it is available, and then take more specific data when it is available in a structured way, to also take it into the index. And then we also have some linguistic, statistic, machine learning approaches which are used on book excerpts already. So I think we will also produce some excerpts of the content, which we can then take for statistical linguistic processes to generate categorization of the pages, to also have the additional metadata that tells us more about the content.
Thank you. I would suggest investigate large language models, because it's trained on the web.
Yeah.
Therefore, it should be really good for extracting metadata from web pages.
Yeah. So we actually have an AI project.
I have this intuition.
We have an AI project which is running next to the web archiving endeavors with a colleague in my office, and he creates uses large language models for things like that, or language models in general. Yeah.
Let's keep in touch. I want to see the results. Maybe next year you come to show.
Yeah, sure.
Thank you. Thank you very much. So, our last speaker has been working, they had a presentation early this morning, so he's working, quite busy, working a benchmark for ontology engineering using large language models. But right now, he's going to talk about the project STAR Digital, which is about lessons learning on ontology engineering in the domain of steel, right?
Yes.
Steel domain. So, without further delays, please welcome Dr. Lars Peter Meyer. Thank you very much.
Thanks, Edgar. I have no doctor, just Lars Peter Meyer. Okay. It's my name. Okay. I want to give you an overview on the lessons learned from our research project, STAR Digital. There we were happy to work with the material science area. And for us, it was a real pleasure to work with real-life problems, real-life things like steel processing, the steel process workflow, some real results. The project was part of the platform Material Digital, and we will work together with our partners, the Max-Planck-Institut für Eisenforschung and the Fraunhofer IWM, and us coming from INFI. The project ends now next month, so we're in a perfect position to give you the lessons learned, what worked out and what was not such a good decision. We were tasked in this project to collect the vocabulary and the knowledge and get it in a structured way in the knowledge graph. And similar as most projects probably had this problem of bridging the gaps between the different domains. The domain knowledge on the one hand side and our ontology knowledge, how to engineer good ontology on the other hand, and to build some houses, not intersection, but the ontology parts between this. 3 years ago, I was here already on the Leipzig Semantic Web Days and got a good feedback to use spreadsheet interfaces for this. And special thanks to Essenza, which provided us with a good template and more ideas how to do this right. And actually, we were able to collect this way, use the spreadsheets to collect everything needed. We were even able to collect references. We were able to do drop-down menus. And the nice thing there was Excel is very, very well known in the domain. Nobody has problems using the software. It just works out of the box. We could choose which cloud provider to use. If we could use Google, we could use Excel online, we could use OnlyOffice, everything worked there. just out of the box, really simple solution, and our domain experts were happy using it. For converting it, we used YAML and RMI mappings. I guess I don't have to go into detail there. And during the project, we found out this very generic structure was not working out. They liked it, they provided some terms, but then we found out they wanted to collect more details on many more concepts. And this structure we started using did not have fields for this specific attributes they wanted to input, like the units used for a typical term, the norms. This is based on, of course, one could do this, but it would have been complicated. So we adapted during the project and used a very specific sheet structure. But still, we were able to do this with the same concept and published our tooling as Excel to OL tooling on the GitHub, open and available. Our feedback here was we liked links and multiple inputs are difficult actually to handle on spreadsheets. It's possible, we are even able to do this with drop-down menus, but always we were struggling a little bit. We checked out maybe Airtable or something like that. Would be better, but then again we would leave this Excel out-of-the-box experience for the users. RMA, we like using it. It's a nice technology, but when really doing the mapping, often we found things that we were not able to do it directly with RMA mappings and have to find ways around that. But our approach was adoptable, and again, Excel just works with the domain experts. Really, really easy software. No adoption necessary. Then, again, for translating this, we had a small architecture there. We started with tables in the beginning, then we had a nice pipeline and published it to a documentation, web documentation. We used the Git repository and the quit store from Nathaniel and published it to a data space management system from our partners. And again, this pipeline was one of the things we developed in the project. We decided to use Nextflow as a workflow management engine. That's common in the bioinformatics field. Has pros that it is working with Docker containers. And we realized that even with a couple of modules, which we were able to publish, but coming back to the feedback, Nextflow sometimes we were struggling with the overhead. You had to describe it in a very specific way, the modules. Debugging, actually, in this workflow was a little bit complicated. We were struggling to find the problems. There was some support for it, but still, it took some time. But the automation I wouldn't miss, but I guess here it's no news over that. And with this modularization, we hope some of the modules at least could be reused. They are published. For publishing our results of the project, we decided to go for the W3ID namespace organization and to use actually GitHub pages as persistent storage. Our decision was we wanted to have something that would stay online even as our project ended now and would need only low maintenance. And we wanted to have something with content type-based redirection capability, so we have it human and machine readable our results. That's all possible with this solution, but again for the feedback, where's the problem? This real world configuration was a little bit difficult. There are many corner cases when going into detail. So we developed this W3ID tester solution where we could define some test cases and check if this works with our configuration. And again, we published it. This was already the negative point on this. Positive was we actually really had low maintenance. I don't know if we had one reconfiguration in the whole project, so I have good feeling that this will stay with low maintenance, and we have good chances that our results stay online for a longer time and not produce the famous 404 errors like most projects at some time in the future produce. Due to the time, I would skip the further experiments we have done, but just come to the conclusion. So we had this tables input, we had the CI pipeline, and we had the solution on the storage of the results. And I want to stress this is, of course, not my whole result. This is a team effort of the Style Guitar team, and especially Kiri Brulert and Norman helped me there. So I'm done, and I hope I catched up a little bit with the time. I'm open for questions.
Great, thank you very much. So now come the moment, if you don't do the questions, I will make them. So, anybody? I have actually two questions. You mentioned about the workflow.
Yeah.
And it seems that this tool is more used, the Nextflow is more used for biomedic domain or something like this. And there are other workflows engines available in the market, even open source. Some of them you can even do programmatically and so on. Is there any particular reason why you decide for this one, or?
Actually, I can't remember the real reason for selecting it. It's 3 years ago. A specific feature is it's open source. The workflow parts, it supports modularization. It supports Docker containers for each module. We just had to write, I guess, something like Ruby or something like that code, and could reuse our existing Docker containers. And we're able to work together with some other projects which have chosen the same.
Yeah, I see. So you didn't try out, for instance, Airflow, which is actually community is based here in Germany, or there is an IBM also, I think it's called Neptune or something like this.
We tried some solutions out.
Some solutions.
But our feeling was to go with Nextflow, but still handling the workflow this way, I guess, with all the solutions. It's always difficult to define the whole solution, the whole workflow, and then for debugging coming back into one small part and finding the solution there, or the problem there.
Can imagine. For the client, you say that you have a client. This client is to run the pipeline based on your workflow, Nextflow, or is because you mentioned that you using Extensor, and we have a very easy client that do this also orchestration from semantic lifting. And are you using that, or
I don't know which one you're referring. We have this W3ID test.
Your last slide you mentioned you have some client interface to run the maybe.
This one?
Yeah, I think was this one. You mentioned something with CLI.
Okay.
Interface.
I think we have no command. The Excel tool is a command line tool.
Yeah.
It's bundled in a Docker container again. It's built on RML function, some helper functions described with a function ontology to be used in the RML mappings, some script around.
Okay.
No rocket science, but it works and it's reliable and it was flexible enough for us.
Okay, great. Thank you very much. Any further questions? If not, I think we are moving then to the closing ceremony with Dr. Trump.
Yeah, thanks, Edgar. So there is not so much ceremony this year because we have no student program this year, unfortunately, because the week we got from the city is so early in the year that the students are not ready from the Leipzig and the HTWK University. So there are two things I can tell you for this closing. The first thing is, as already mentioned at the beginning, in the morning, so we have now, I think, 2 hours until 6 p.m. And I hope I see you at the Moritzbastei. As always, we invite you to the Semantic Beer Garden, so we can have some drinks and also a little bit to eat, but don't come too hungry, I have to say. But you have 2 hours to do this. The Moritzbastei is not far away, you see it. Just go outside of the building, turn left, and walk for some 100 meters. And the second thing I am allowed to introduce and to announce is that we already have a date for the next Data Week. So please try to save the date for the next year, which is from 10th of June to the 13th of June. It's a 4-day slot. The Monday in this week is a national holiday. And of course, the Semantic Web Day will also be part of the Data Week again. And yeah, beside that, thank you very much for doing the talks to the speakers, also because of the discussions in this room and outside. And I hope I see you in 2 hours or maybe next year. Thank you very much.